Okay, well, welcome everybody to Dallas Personal Robotics Group Robot Builders Night, online virtual. Here we are tonight in the first of the new year. Off to a rocking start. We have quite a lot of visitors tonight, and at least a few of us have stuff to share. So we're going to follow the usual format of just swinging around the table, seeing who has things they'd like to talk about or questions they'd like to ask. We'll also probably spend a few minutes ad hoc somewhere, because as a reminder, we have, we're a 501c organization, and as a part of our bylaws and tax status, we have to hold an election each year. That election is underway for voting members, people who are paying dues, and we're going to finish that on this coming Saturday. And as well as this coming Saturday, our monthly meeting, we'll have a planning session whereby we'll get some ideas and such for what we want to do this year. So if you're not a member, I encourage you to think about potentially joining. And if you want to just attend without joining, that's fine too. But Saturday should be a good discussion. So I'm hopeful that everyone will bring their ideas, what they'd like to see, and hopefully volunteering to sign up and either recruit someone to present to us or present something of their own that's interesting. Just take a whole monthly meeting session up. That'd be good. So without further ado, I think we can get started. There's two of us I know of, and so how about if we just go in this order? We'll let Doug Dodson start, and then I'll go. I have a probably 6 or 8 minute thing, and then we'll just bounce around with whoever else wants to raise their hand after that. So Doug.
Well, I've done several things over the last couple of weeks, and one is I've been working on my programming methodology so that I can do my programming in Visual Basic Code, and I don't really have anything to show there. I just make a note that somebody, I believe it was Carl, had talked about being able to use code for the Arduino, and that's true. I still haven't got the debugging working, but I'm sure I just haven't finished looking at the example yet. And it also works well in Python, so I'm feeling pretty good about that. And then the other thing I did is I made more progress on my Roby project, taking apart this body part here. I took the cassette player out because I was bored one day and didn't have anything else to do, and I had to make room inside this body to put my Raspberry Pi, which is going to be the thinking part. And then the more fun part is I took my base unit here, which always had these ultrasonic sensors on it, and I added IR sensors on both sides so that I can potentially do wall following at some point. And I added more of the sound sensors on the back, because if I can do this without making a mess, this thing has this wheel here which does not go over rugs very good. And unfortunately, this is the forward direction. I kept thinking I was going to be able to reverse the body on the machine so that the wheels would be the forward. Climbs over rugs real easily with the wheels. But unfortunately, the people that made the thing did a really good job of making sure when you took it apart, you put it back together right. So you can't put the body on backwards. It's just slightly off. It looks like it should work until you get it right up there. And it's like the front has a curve and the back is straight. So it doesn't work unless I want to really get into the mechanics, which I intend to do at some point, but not now. So my intention is that I'm going to create a behavior for when you bump into something or you look like you're getting to a rug or something, turn around and back over it. That's going to be my temporary solution until I just get it driving in the other direction. So that's all fun. I got those sensors in, and I've written the program, but I have not yet tested them because I only just finished writing the program to pay attention to all this. So work in progress. Maybe next week I'll have more details on that. That's about it.
A suggestion,
yeah,
on your side-looking IRs,
right?
You need to point those at a 45-degree angle, not straight out.
Ah, and the reason?
The reason is that if you point it straight out, then when it thinks it's getting too close to the wall, it'll start trying to get closer.
But that would see the sensors.
I totally agree, by the way.
The
I
sensors.
also vote for that suggestion.
What's that?
I said I totally agree. And I saw
Okay.
somebody else.
You have
give us
3
a thumbs
votes
up.
so far for that.
Well,
Actually, Doug, it's a bit counterintuitive. I've had these guys wall at me about the same subject a few times. But basically, if you think about it, if you've got the robot perpendicular, I should say parallel to the wall with the sensor perpendicular, and then just think logically about as you turn, the distance gets further and further away, but it only does it, and it does it bidirectionally. Whereas if you angle at 45 degree, as you begin to turn into the wall, I think, correct me if I'm wrong, but as you get into the wall, you get to the point where the sensor is actually perpendicular, and then you'll actually be getting closer to the wall. Is that right? Something like that.
that all kind of makes sense. My intention with the sensor, and it could be because I misunderstood the documentation, it's right now set up for 1 or 0 digital read. Is it within range or not? So it's not telling me distance. It's just telling me, does it see something? And I intend to have the distance set relatively small. And then my other part of my intention is that my ultrasonic sensors are giving me distance, and the wall sensor on the right is just to tell me, am I running along close to the wall? I'm not expecting to know how far it is. I'm also going to be at some point putting video on it. So all of those will be just kind of informational at some point.
So with the IR being binary, the suggestion might matter a little less, but I think it's still valid because, okay, so you're going to get a 1 and a 0, right? So if this is the wall, this is your robot. I don't know if I can do this, right? You're still going to have the same situation where you think you're not actually seeing it anymore, where in reality you're turning towards it.
Yeah, I'm definitely going to take
exactly. There you go.
I'm going to take that suggestion to heart, because what I've found with my limited knowledge of all these sensors is they never quite work the way they say they do. And so you have to pay attention to the fact that maybe it's going to give you a false read. Maybe it's not.
No, it's not that it gives you a false reading. It's that the geometry of the thing is such that as you are either turning away or turning towards the wall, you get a false answer.
Right.
Yeah.
So all of that'll be.
Doug, as you turn, as if you're straight to the wall, like parallel to the wall, you get, let's say, 15 centimeters. But as you turn either towards the wall or away, the distance will fall off and the sensor will think you're actually farther away. So as you turn towards the wall, even steeper towards the wall, the distance will even get longer.
Yeah.
That makes sense?
To think about. I'm glad I haven't started writing the real code for that yet. So these suggestions will make it easier for me to write it correctly the first time.
Well, it's more essential positioning thing, not so much a coding thing, right?
It's really a mechanical issue, not a software issue. If you have the sensor pointing straight towards the wall, you're going to get screwed up. Guaranteed.
Doug, that's your first real mistake, that you think you're going to write the software correctly the first time.
That's not my first mistake. Trust me. But I hear all what you're saying, and I really appreciate the feedback, because that's one of the things I get out of this.
Well, Doug, what I did is, this is my front sensor. And if we're looking, if upwards is actually forward on the robot, when I first built it, I did have it aiming straight out the side, but as per these guys' suggestions, I used to have it this way, and now it's actually angled about like that. And it's exactly as they say, as you turn in, you get closer, whereas if it was straight out this way, as you turn, it actually gets further away.
Right.
Yeah. In any case, I think you'll figure that out. But
right.
It also helps, Doug, with the how you detect a inside 90-degree turn.
Mm.
It will help you there, because you'll start to turn if you hit the corner even before your ultrasonics. Otherwise, it'll back up your ultrasonics. You'll get a kick. Go this way. Where if it's straight out against the wall, you kind of lose that advantage. Now, I don't know if it has to be 45 degrees. It just has to be 45 is probably optimal. If I think about it, it gives you the most allowance. But it can't be straight on.
And another interesting point about all of that is my intention was to say, is there a wall to beside me or not? But technically, I don't care if there's a wall beside me because that's not the way I'm going. So if I'm going forward, I do need to know about that wall that's kind of ahead of me. So I need to be looking that direction instead of straight to the side.
Well, you have to, when you really play with it, with a wall following, you got to be able to handle the inside corners and the outside corners. You have to have a strategy for the outside corner. What happens when the wall disappears? What do you do?
I should turn in that direction, I would think.
Yeah. And so this again will help you there because it'll buffer. You'll find that if you ever get where your robot is turned too much, you'll just hit the wall. I mean, so you have to keep it. You can't. Let's see if I can do this. You can't go like this, because if you get like that, then things get weird. Okay.
Mm-hmm.
So if you have that's an indoor corner. Think of it that way. When you come by and you miss the corner and you start turning into it, if you have to have, that's one of the other situations you're going to have to check.
Right.
All right.
One thing that I've found helpful on my firefighting robot, where I use combination of IR and sonar, is, I had a level, base, a platform, and the sensors were kind of mounted on top like that, right? And obviously facing, towards where I'm going and the side. But I had a setup, just very simple mechanically, really, a screw going through the bottom where I could turn it, right? So it wasn't like permanently, mounted into my base in such a way that it's rigid. I was actually able to adjust the angle of most of my sensors so that I had a chance to really play with it until I get it right.
That's a good point.
Now, there's one other thing too here you have to kind of watch, especially when you lose the wall, or if you're counting on ultrasonics. If you're making a quick, a short distance measurement with ultrasonic, they return pretty quick, okay? And you can get a pretty good rate. But if they ever get where they're looking into a long distance, they'll go to whatever the maximum timeout that you have set for that particular sensor. And you may find that that's way too slow for you to get an update. Okay.
So just to make sure I understood what you just said, if the wall is out of sight or far away, the answer comes back slower?
Yeah, otherwise, the front will come back slower. Okay.
Good to know.
So I mean, you can check this out. One of the things that I used to do on one of our tabletop contests was I would look for a can that was on the table, and what you quickly found was that when it found the table, found a can, because there were several around, it would go toot, 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 and when it was shooting out into the crowd, it would go doot, doot, doot. And I actually indexed the turn based on the sonar reading, so you could literally see how fast the sonar was coming back for you.
But you don't have to wait for it to time out, right? I mean, that's under your control, under software control.
Well, okay, there's certain, the new ping library that's in Arduino does have where you can set that distance. But some of you have to be careful about what sensor you get from China, because a lot of the sensors from China don't have up-to-date software, and they literally time out. I mean, there's no intervention. You can ignore it. You can say, okay, and some of them you can reping, but not all of them can be repinged. So you just have to take the sensor you have and give it a couple of tests to figure out what you got. Because that's one of the disadvantages of buying, an 89-cent sensor from overseas. You don't really know quite what you get until it kind of shows up.
Or even if it works.
Usually they work.
Yeah.
Usually they work.
My plan is that I've got the loop running, the loop talks to every sensor and says, what you got? And then I'm going to combine all those what you gots into a string that I send up to the Pi if it needs to make a decision. But down on the Arduino, if I'm close to something, it'll make a decision based on, oh, I got something close, I need to do something now to avoid an object.
Yeah, and that's why they're one of the reasons why they're so helpful, because usually you're trying to determine if there's something close to you. But
Right.
the problem you get into is like, if you have a sudden change from something that was far away to something that's suddenly near, well, it's still waiting for that far away reading to return. And then when you hit the new one and the wall's suddenly there, it pops into it. I'm just saying there's some, you after you play with it on the floor, you'll find all of these things.
Right.
I'm just giving you a heads up.
Good to know. It's like somebody said the other day, sometimes they have to average their things or throw out the odd ones in the middle of all the others, because you just get those fake readings in the middle of something else.
With ultrasonics, that's a little bit of a pain because, like I say, they're so slow. I mean,
yeah. Doug D, there was actually going back on that one. There was, I think it was David Anderson and I were both looking at different ways of doing that, and David was suggesting that because the robot can't react that fast, that those spurious numbers won't cause the robot to change much, because by the time 20 milliseconds has passed, it's already basically forgotten that, because the robot couldn't react that fast. I was the one who was actually using the running average.
Oh, okay.
But maybe David's right, and that's not even necessary. I don't know.
Right. We'll find out when I'm starting to actually test it running around on the floor.
Yeah.
I know that sometimes in my test that I've done with just the forward-looking ultrasonics, it'll run up on the wall sometimes before it actually turns. And I think it has to do something with the speed of reacting to the sensors. Because 3 times it'll see the wall and turn, and 1 time it'll just go right up there and say, I'm too close. They don't give an answer when they're too close.
One of the things that helped me on that one was that when I'm running my robot, I have an SSH connection into my Raspberry Pi, and I can actually see the console messages of what's actually coming off the robot. But if you're not doing something like that, the other thing I've done is I use these little RGB LED things, and you could just take any RGB LED and, let's say, change the color or put a number or some kind of indicator of distance. What I was doing was having a rainbow color that went from red as close to purple as distant, and I actually set the color, and you could see what the sense. Actually, I think David did the same thing, is he was putting LEDs on his robot so you could see what the sensors were doing.
Just for debugging. Yeah.
Yeah, exactly.
Yeah, that's good. My intention is those strings that I send up that says, here's what I currently know, I'm going to be saving those on the Pi so that I can review them later. But I haven't got the two actually talking together yet. I've been working on my serial interface, but I was listening to John a couple of weeks ago talked about this safe string thing that didn't delay the Arduino, and it sounds interesting, but it's so new. They're still making changes to it. So I'm not ready to implement it yet. So anyway, thanks for the info. I'll release the floor to somebody else.
Yes, that's pretty good progress there. All right.
Wait a minute, before we leave, Doug, there was one question I had. Doug, you said you took out the cassette player and had a nice rectangular hole. Yeah, I was wondering if you could use one of those,
A screen type thing?
Well, no, I was thinking sort of those things that they put hard drives in, and you can put your Raspberry Pi inside of it. You know what I mean? So that, like a hot swap box.
Right.
I might make it easier for you to do maintenance. I'm just an idea.
Yeah. I was actually thinking that I would use that for like a touch screen that I could pull out with a keyboard or something in case I wanted to do something at the robot, but I haven't fully decided yet.
Neat.
I bought a little, somewhere around here, haven't even got it out of the box yet, a little keyboard thing that I'm going to stick in there, hopefully never have to use much. And there's always the Wi-Fi in and all of that kind of stuff too, the SSH. It's still definitely a work in progress. Not all decisions have been made.
Cool. Okay. Okay. I think I'm going to jump in now at risk of, hopefully it's not too long of a overbearing thing, but I have been making progress with hover sims, so the McCann wheel platform that I have. And I have this nice little video here to show what I've done now over the weekend was to kind of calibrate the encoders on the wheels on different surfaces. So this is about 4 minutes. And if you want to, you can follow along with the code that's out there on GitHub. But at first, there's a few of these encoder ticks to distance. And so I just made it go forward, sideways, and diagonally on different surfaces. And I tried to measure how far did it go and how much did it deviate. So that was a rough tile in a kitchen. This is a semi-smooth cork floor, which was pretty reliable, pretty repeatable. And then it also moved diagonally. So it was pretty repeatable, I thought, but some variation. But then it varied a lot by the different kinds of surface. So just looking closely, this is what that tile looks like in the kitchen area. I hope this is coming across not too jerkily.
Yeah.
Is it coming across? Okay, good. This is the cork floor, so you can see it's got a little texture, but it's nowhere near as much texture as the tile. And then I also did measurements on a builder grade carpet. So it's just some cheap, nappy little carpet. And there's one other carpeted surface that I did, which has got quite a lot of texture to it. And you can see the texture there. I moved it around just so you can get a sense of how much variation there is. So the interesting thing here, and then I have some data to show, some charts and some conclusions, but I thought I'd show the videos first.
So you're saying that that last carpet, you were able to transfer on that as well?
Well, watch and see what happens. That's what's interesting. So forward on that rough carpet, look at that. It's pretty straight. Who can argue with that?
And it's even moving.
By eyeball? Oh, no, it translates. It moves fine.
Yeah, I'm jealous.
Watch this. Watch what happens when you try and go in a straight diagonal line. You know, you can see it kind of wobble around a little bit on its axis and jigger. But the real joy comes when you try and go full on sideways. Just look at that.
Yeah.
It's so lost. It's so totally lost. So totally lost. So then I had this other exercise I call translate circle. So again, it's a slightly advanced commit, not that much of a change, but it's a different commit. So you start that routine up, and it attempts to just translate around in a circle. There's whoops. It samples the 360 degrees 40 times in a full translation. You can see, you know, it's kind of messed up there on the rough tile. On the carpet, homogeneous carpet, it does a little better, but it's got some kind of bias offset. See how it's rotating? It's heading a little bit.
Is that the emergency stop button right there, the red thing?
I need to wire it up to be that, but it's not at the moment. Now watch what happens on our favorite rough surface. Oh yeah, it's all out of control. So, and we're working towards the conclusions, but there's another couple of videos clips in here to look at. And that is, well, what happens on a like polished concrete in the garage with cracks? So pretty good, really. I mean, I thought, because right now it's only moving the wheels based on a velocity loop on the wheels themselves. And it wound up pretty close to the center, right? So here's some of the data and some of the conclusions. Yep, it's coming across. So basically, like this is showing builder grade carpet, cork laminate, and kitchen tile. And then the left axis is distance traveled, and then the blue one, and then the orange one is what's the standard deviation. So I did 10 runs of each dimension on each surface. And you can see that, you know, even just between these three, cork laminate, kitchen tile, builder grade carpet, 132.8 ticks per inch up to 134 ticks per inch. So the average was pretty close. And even the standard deviation, I mean, look at that. The worst one on the kitchen tile of those three was 0.3 ticks per inch. But now, if you look at the sideways chart, so the average, and this is running the same program, right? So it's attempting to go the same distance, the same velocity. So the cork laminate had 135 ticks per inch. Kitchen tile was pretty close to that, but that rough or the builder's grade carpet was 170, almost 165. So there was a lot of slip in the builder's carpet, right? A lot more ticks to go the same distance. And the variation you could see, well, it wasn't all that much. It was pretty consistent for any given surface, 0.2, 0.4. So forwards and sideways were relatively consistent by surface, but between them. Now diagonal is where the fun happens. So diagonal, and this is just comparing the builder grade carpet to the cork laminate. And the average here was 186, call it, versus 216. And the standard deviation, look at that. On a standard deviation went all the way up to 14 ticks per inch on the cork laminate. So a lot of variation. So bottom line, in my view, you know, they might be just fine for motor velocity PID loops, but I'm going to stick with an IMU for heading and something else for measuring position. And that's the net of it all.
Well, Carl, thank you for that. That's really depressing.
Well, but Murray, you know, now I'm inspired because the answer to this for me, I believe, is going to be either the those Pimoroni optical flow sensors, which you've gratefully gotten some tests on already, or I might look at what Ray has been doing with the OpenMV M7, because with the OpenMV M7 with the camera, I've understood not only can it measure translation, but it can also measure rotation with one camera instead of having two of the Pimoroni optical flows. So
yeah, you know, the only reason I'm feeling depressed is, of course, you guys know that I've got all these wheels, and I think it was last week or the week before we talked about this, and I was like, okay, I might give this a try, but I'm not sure who it was exactly. Maybe it was Kareem was just saying, just forget it, they're useless. And you've confirmed they're useless in terms of like PID controller and all that.
Well, for position estimation, unless you're on a very consistent surface, I don't think on a nice hard surface that's homogeneous, I think you can actually get reasonably decent results. But as soon as you start to get some dust in the matter or some roughness or some softness from the carpet, just forget it.
Well, yeah, and you can use PID controllers to get your velocity. So you set the velocity, you know, on all four wheels exactly what you want, and you're using the PID controllers for velocity. No problem with that. But what the actual wheels are doing on the ground obviously varies a great deal depending on, you know, weight, distribution, surface, all that stuff.
All that stuff.
And I'm just actually getting into the beginning of starting on the design of the hardware of this Mecanum robot, and I'm thinking, oh God, maybe I should just go with regular wheels.
Oh no, go for the fun, take the challenge. Join me. Yeah. And we have, by the way, Jonathan has this, not to snitch on him, but Jonathan bought the same platform that I just showed in the video. So there could be as many as 3 of us putzing around with this to see what happens.
Well, thank you for that. It was quite enlightening.
Yeah, no problem. You're welcome.
Carl, I have a question. Maybe I missed it. How did the clicks per inch when the robot is traveling straight forward and backwards compared to the clicks per inch when it's traveling sideways?
Oh no, thank you. That's a very good question. I did look at that. I forget offhand exactly, so let's just look at the data. So here we have, again, see, there it is. So this is forward calibration, and let's do the consistent one, which on here was the cork laminate. So the cork laminate was 130, call it 132.9 on average, with a standard deviation of 0.15, okay? 139 ticks per inch with a standard deviation of 0.15. Sideways on the cork was 135, so 135 versus 132. So you could start to see some loss because it had extra rotations, but the standard deviation, instead of being 0.15, was way up at 0.4. And diagonal must be the really challenging one, because here, instead of like 133, it's 189, 186 with a standard deviation of 14. So diagonal is where, like, if you try and do that translate circle, it's just, you can't rely on the encoders at all. I mean, it's going to do something. And I suspect there's also an issue in that, I mean, without figuring out the mechanics very well. Oh, wait, what am I? Yeah, without trying to get into that nice presentation someone showed the other week. You'll notice on this platform, it's taller than it is wide.
Oh, yeah.
So I think the force vectors don't point to the middle. I think the force vectors are offset. So when it's doing diagonal, I think it's going to be a little squirrely versus if these were on the corners of a square.
Yeah.
Well, they look to me like they are on the corners of a square, even though the platform itself is rectangular.
Okay.
You have a handy measuring device?
A handy measuring device. So let's go axle to axle. So we have here.
No. Center of wheel to center of wheel.
Okay, good point. 8.5 inches front and back. And then this one is 7.5 inches. So it's actually wider than it is forward. How about that? It's wider than it is tall, because it's 8.5 this way and 7.5 inches this way.
Yeah, we kind of talked about this months ago, that symmetry, apart from weight distribution, that symmetry does seem to be kind of important.
I would think so. And that's where, I'm really interested, because once I can get so my next step is to add an IMU to this, so that at least it maintains the same heading. Because I noticed on the garage floor, the polished concrete, I noticed that because I started it goes instantaneously from 0 to max speed in one direction, and I've noticed some wheel slip, and then that causes it to get offset just from the very start. So what I want to do is kind of slow it down and repeat that test and see what it does if I can get closer to no wheel slip. And then the other thing I noticed is that, like on the polished concrete, I noticed that it still has some kind of tendency to do a clockwise rotation as it's translating in a circle. So I noticed that if I would give it just a manual nudge as it's translating to keep the heading straight, that it seemed to line up better, closer to where it started. So that's what I want to do next. I want to put the IMU on there, see if I can maintain the heading, try the same thing at a slower speed, and then either from a top-down camera or from an optical flow or some better position, I want to see how closely it actually gets to translating a circle versus an ellipse.
Just to reply to what Murray said, I haven't worked with mechanic wheels, but my own experience with four-wheel drive skid steer is that if you think about it being wider than it is long, what that means basically is continue that on until both wheels are in the same place. Basically, the closer they are together, the more they are on the circle, on the great circle when it spins in place. The further they are from each other, the more they have to scrub sideways to spin in place. So if you think about those little front loaders those little four-wheel skid front loaders, the wheels are almost right next to each other. So that they're, as I say, they're closer to laying on the circle than if it's longer than it is wide. That's all.
Okay, the question I had, Carl, you had, can you look at your data again, and what is the ticks per inch for the diagonal versus the forward? The diagonal is more, right?
Like cork laminate diagonal. Here you go. Cork laminate diagonal was, call it 187 ticks per inch on average. Whereas
And the straight?
straight forward was 132.9.
Okay. Now the question I had then was, since you're diagonal and you're manually starting and stopping the robot, right? You have a control.
That's what that commit is. When I referenced that commit, I just push the button, and at that point, then it moves it up to full speed in 4 steps. First to 10, 20, then 40 ticks per sample, which is 50 milliseconds, and then it runs for a while. Then it backs back down 40, 30, 20.
So what I was saying is, if you're diagonal, each forward is going to be small. For the wheel spin or the encoder ticks, the forward movement is going to be less. So if you're visually stopping the robot when it reaches target, it would have a higher number, because for each tick, you don't have, this way you got a full forward moment per tick. This way, and I don't know what the angle is. You got some
angle.
Yeah. So that's consistent, as you would expect.
Yeah.
Okay.
Yeah, it's not surprising, but
okay. No, I was just saying if you knew the angle on the wheels and you took that correction factor out, how do they show up? Do they come close together?
That math's above my pay grade. I don't know. It shouldn't be that difficult. But I haven't done it yet.
Okay, gotcha.
But I agree. That's an excellent question. I just didn't do it yet.
I got a little something. I first of all, I wanted to thank David for pointing out the sign magnitude option on the L298. Is it 298? Yeah. I tried it out, and yay, verily, it does work. I did seem to have some crosstalk occasionally, which I couldn't explain. But if I set them, the motors, there's no issue. The second thing that I was working on was, remember I was saying that I did not like the fact that the wheel on these little robots that I've been building is unsupported, and that they wobble. If I can get this out. Oh well, anyway, so they would wobble like this. So what I did was, last week I showed a machined axle with a thread on the end of it. Machined axle with a thread on it. I don't know if you can really see anything there, but just believe it. There's a shaft, and then there's the threaded end on it. Well, I said, it'd be much easier and easier to put the bearing on if I just cut a chunk of rod, and then center drilled the end, and then cut the head off of a screw and screwed that in. And that way I could press the bearing to where I wanted it, and then just screw the screw in, and everything would be hunky-dory. And so right now, that's where I am. I have this. I can get them back screwed on here again. So I have a little pillar block holding up that can be supported by some additional stuff. It's got a rod a rod going through it. There's a bearing in the pillar block, obviously. And so anyway, kind of looks like it might be a workable idea. I'm going to see how it goes. So that's all I had to say.
So did you machine it yourself?
There's not a whole lot of machining. I did use the lathe to drill the hole in the center of the rod, but I think some of that was a poor choice of rod and bearing. Somehow when I started this out, I ended up thinking, well, I want a 4mm rod and a 4mm interior diameter bearing. It would have been, bearings in that size all cost the same. It would have been much smarter to do, say, 6 or even 8mm. Well, probably 6mm. Then I would have had essentially a rod that was about the size of a 1/4 inch. It would have been easier to drill a 3mm hole in a 6mm. I'd have had a 1.5 mil on each sidewall.
Yeah.
Where with a 4mm rod, I only have a 1/2 centimeter per sidewall. So that's kind of a bad design choice. But now that I've got like 36 inches of 4mm brass rod, it'll probably be 4mm.
Yeah.
But it wasn't that hard on the lathe. But I was trying to set this up so there'd be something that anybody could do. And there are ways to center holes accurately using a drill press. Where you essentially put the drill in the drill press in your vise, in your rod in the chuck, and that way, when you come down on it, it will actually do a very good job of center drilling. So, but it's definitely easier to press the bearing, and it's much easier to just screw in a stud than it is to actually thread the end, size it and then thread the end of a shaft. So you could do it. I mean, I'm sure somebody who's really good at machining could do it without any problem, but it was easier for me. This way, 4mm brass, and which should have been 6mm, and 3mm hole, and turns out it's a number 40 screw, which a number 40 drill, whichever that is, or a 2.5mm drill, which I didn't have.
Yeah.
Anyway, got it on there. And so now I'm going to make another one and put it on, do a laser cut base, and then see if it helps.
Mm-hmm.
Yeah.
Cool. That's good progress.
Yeah, it's kind
Take
of
it.
my Destiny 2 time, though. I don't tell you. Anyway.
All righty.
For those of us who don't have a metal shop, and some do, some don't. I can do plastic and wood and stuff like that, but I can't really machine any metal. I have to go out and search for parts from various sources that might work. And so, for example, what you were describing is like this little thing, which is a 3mm screw on the end of a threaded. It's basically what you described exactly. On this end is a threaded rod 4mm. And then you can stick a bearing on here, and this is how I get these guys. But this is all OSEP stuff, and unfortunately OSEP, I think they're in British Columbia, they won't sell parts. They sell kits of a whole bunch of things, but they don't sell parts. And so I've been looking around, and of course Make Block is the same size of these things, 16mm by 16mm grid. They're not quite the same because the Make Block ones actually have threads on the end, whereas these ones you have to put these little inserts on the end. And the problem is they won't sell, OSEP won't sell these things. So the question I have is I'm trying to find, like OSEP sells like hundreds and hundreds and hundreds of little hardware parts. And some of them are really cool and useful, but I can't find anybody that isn't a B2B, like a business sales of those parts. They'll sell little kits and things like that, but nobody seems to sell like a lot of stuff. And the only vendor I've been able to find is in Belgium. And
how about Alibaba? Surely there's some.
Alibaba has a little bit more than, let's say, Robot Shop up in Canada, but even they don't sell. Like if you go to the actual Make Block website, they sell like just huge amounts of hardware and different kinds of beams, square beams, rectangular beams like this, thin beams. And as I said, I'm starting to look at the design of a new robot, and I'd like to use these Make Block beams and some of their hardware components as well. but I can't, like, they have a really nice little tiny caster wheel that you can, and a mount, so you can actually mount a nice small ball caster. But I can't, the only place I can find is in Belgium, and I've emailed them and they can ship to New Zealand, but it seems kind of daft to be paying euros for something that comes out of either the US or China. And they seem like nice people, but the prices are fairly high because I'm buying in euros. But is anybody in the group here ever bought any stuff from Make Block themselves?
Just
No,
the
but-
stuff through Tanner's.
Yeah, we were kind of spoiled. I mean, Tanner had it on sale for so cheap that
Yeah.
it was, there was no reason to go to Make Block and just buy it at Tanner's. But now they're getting Tanner's.
Well, and screws and nuts and stuff like that. I just walked down the street to Elliot's.
Yeah.
Oh yeah, yeah.
Oh,
I mean,
yeah, well, Elliot's, please, yeah.
this morning I was there at the local place in Poruru, which is the town next to mine, and I spent $37 worth of stainless steel hardware. So I can get they've got, it's an amazing shop actually. So they've got all the screws and nuts and stuff like that, but it's more the kind of specialty hardware like that can be used for robots, and the little aluminum beams and stuff like that. It's really, really impossible to find. So I might end up buying from Belgium, but it's like about not twice the price, but it's quite a bit higher than buying from, let's say, China. But I couldn't find anything on Alibaba.
Some other places that might have some interesting stuff. One is Rev Robotics, okay, which is here in the Dallas area. By an he was actually founded by an ex-member. And then there's the McCasters and Carr.
McMaster Carr.
McMaster Carr. Now they have everything. So you probably you might just have to figure out what it's called, and whether it's a single threaded in stud or whatever they call it, and they probably have it. So that might be another place. They might, and another place that I might consider for looking at is openbuild.com. They deal with
I think it's
homemade CNC machines.
Yeah.
So they sell all sorts of extrusions and stuff like that, which good. And another place that you might that it's a little bit peculiar stuff, but it all hangs together, and that's Vex out of Greenville, Texas.
Yeah.
They also have some stuff, and they have several lines. They have plastic stuff, they have metal stuff, they have FTC competition stuff. So you have to look around and see what they have.
Yeah. Okay. All right.
Yeah.
Thank you very much. That gives me lots. That McMaster Cars. I used to live in Sacramento, California, and there was an old hardware store that had been there since like the 1860s. They had wagon wheels in the wall that they had been selling from then, and it was one of those hardware stores that you just never find anymore. And it looks like McMaster Car is kind of that kind of place, isn't it?
It's sure that
It's got everything.
Cool.
Yeah.
It's not cheap, but it's got everything.
It was
I wouldn't buy my really three. The other thing is the stuff they have is top quality.
Yeah.
And I mean, like if you buy a screw from them, it's going to be a really good screw, as opposed to if you buy something from Amazon, which is being sourced by who knows what, might not be so high. It might work, but it might not be so high.
Yeah, I've got stainless steel screws in my front fence, and I live near the ocean, and all those stainless steel screws were not stainless.
Yeah.
Has anybody on these robot builds? I've always wondered, but I've noticed that Lowe's and Home Depot, in the furniture hardware section, there's all kinds of cool little fasteners. But they really help the furniture go together quickly and easily. And I've often thought that they could be repurposed to help join things in the robots. Has anyone else looked at those?
Oh yeah, and IKEA, they have they used to have a section where you could go through and they had just like bin after bin of loose hardware, and I'd always go there and you know, gather my loose hardware. It was all for free. The thing is, now the last time I went there, it's gone. So maybe I've used it. I don't know.
Well, Carl, we even get that kind of thing here. The local hardware stores here have this one line and the big bins of hardware. The only problem with those is they only go down to, I think it's 5 mil. So
Oh,
they don't,
yeah.
if you're using it for the larger components of putting together a larger robot, but most of my robots are put together with 3 mil and they just don't carry that.
Yeah.
Well, my default size, because I'm Imperial, is 6, the number 6, and Lowe's and stuff do not have very, very small selections of number 4s.
Yeah.
So if you almost always have to get number 4 hardware if I need it off of Amazon. And if I'm going to get number 4, I just usually get 3 mil. I just buy the metric because I can usually get a better deal.
Yeah. Well, I'm really lucky. We've got this place called Coastal Fasteners, and I was just there today, and they've got it's like a warehouse size. And in New Zealand, you just don't find this kind of thing, but they're like the supplier in the area, and I can go all the way down to 2.5 with them, so it's good.
Wow. Yeah, this was a thing from Make Block. It was a little kit, and it had I think that's what you were. Oops. Those are a smooth shaft on one end, 4 millimeter, with kind of like a collar in the middle, and then a threaded shaft. They had timing belts. They had like 2 different pulleys.
Yeah. I know that kit. Yeah.
It 4 millimeter ball bearings in a little case there. But yeah, that was a Tanner thing. Oh, and shaft collars. Those are the shaft collars. But yeah, it was all in one little bubble pack.
I know. I probably have a couple of those. I didn't even think about it.
Yeah.
Yeah.
Yeah, and I think that particular kit you can get on Alibaba and in the Chinese shops. It's more the specialty stuff like the casters and all these little beams in different sizes that I've been looking for. But I could just make the whole robot out of 3 millimeter Delrin plastic sheet, which I've got quite a bit of. But it's nice to use the nice little beams and everything when you can. On this robot, it's the Mecanum one. I'm really, really trying to save as much weight as possible and make it a small, lightweight robot, because my other robot I'm working on weighs like 5 or 6 pounds. It's a pretty heavy robot.
Cool. There's the nod. All right. So who else has been busy this week? Busy Beaver, off to a new year with a great start.
I got some show and tell. That's about that and whining about Ross. But there's always whining about Ross and PID tuning. So there's always lots of whining about that. Yes.
You're saying PID tuning in Ross? Is that what the
well, eventually, yes, but no, not at the moment. They haven't collided yet, but it's coming.
Now, if you're tuning Mecanum wheels with PID loops in Ross, then you get the trifecta.
Well, we get the trifecta. Well, I'm glutton for punishment, all that kind of stuff. Yeah, I can show off a little bit if you don't mind. Do a little show and tell.
Please share your screen.
I am sharing. Showing and telling on my camera right now. Most of it, you see my cat's butt. So that's a nice video that Carl has up there, showing off the Catzilla. Because I usually get catastrophes. Come here, Ralphie. You got to get down. Come on. Yes. I know. Everybody loves you, and you're the best ever. Yeah. Thank you. So I just want to do some show and tell, I guess. So if you'll pin me up so you can see me all full screen there, you should be able to see everything I'm about to show you. I got a plethora of these things in because it was cheaper to buy 10 of them than it was to buy 5 of them. Well, it was almost as expensive because the shipping didn't go up any at all after I got about 4 or 5 of them together. So I'm like, okay, I'm buying a bunch of them. They're like $2 or $3. And these are these analog current sensors. Basically, it throws an analog out. It's like a tenth of a volt per amp or something along those lines. I forget what it is. I was just looking that up to get a deal in it. But so it got a bunch of those in there. So I might have some extra here before too long. This is some more of my fun stuff. I bought this is coming in from China. These two are the holders, same holder. I had this holder. I like this holder. This is kind of plastic. I don't really care for this, but it came in the kit because I wanted to buy a bunch of these blades, replacement blades on them. You're like, well, what would you do with this thing? Because you got a handle and it kind of rotates around. And why would you do something like that? Well,
it's a deburring tool.
It's exactly what it is. And it's the edge on it's got this is on one side is flat, the other one's kind of knobbed up. And so on one of my 3D prints, I got a little something on the edge of it. I grab it and I go down it, and it gets me up and cleans that stuff up really nice. So if you're a maker kind of things and don't have one of these, I got that ugly blue handle, which is probably fine, and all of these blades for like $9. China. And so I think they are, pretty cool. And if you remember a few DPRGs in the virtual robot night, there was a mention of a Spark Fun dumpster dive that did show up, and this is a pound of dumpster dive. I wonder what it looks like. I'll show what I got off in that. I did get my $20 worth. The most useless, I say most useless to me and probably everybody in this group, because we have got a bunch of them already, is a set of Allen wrenches with the ball ends that go from 1.5 millimeters up to 10. I bet every one of us has more than one of these lying around because we lose them all the time and then find them again. And so I don't know what I'm going to do with that necessarily, but $10 at Harbor Freight, so that's half of that. The other portion of it was a women's small T-shirt. Like it's not going to fit my big toe. So, but on the front of it, on the back of it, it's got the Spark Fun thing, and on the front of it, it says "Thank the Maker." On the thing, I know my wife can't wear it. I can't wear it. I'm not sure what I'm going to do with it yet, but that's got to be $10. So there's my $20 right there.
The cat needs that shirt.
Do what now?
The cat needs that shirt.
Yeah,
That's what I thought.
exactly. Okay, and the other thing, I'm going to take the box away on this one. Actually, this box is kind of cool because this is actually useful. On one end of the box here, they've got a resistor chart, and that's how other boxes come. And we have tons of these around here already, but I thought that was a nice little added touch there for who they are and what they do. I got a bunch of this, and each one of these modules here is between $10 and $20. So 1, 2, 3, 4. So that's easily $40 there, or $60. So I did get them. The problem with it is, did a look at, these things are called spectacles. And if you go look up not Adafruit, but a Spark Fun spectacle, these were discontinued like 3 years ago, but there's some coolness about them. They use this audio connector here to connect up to your phone and plug into, that's how they link between all these modules, and then you control motors with them and that kind of stuff. It's got a scratch lock language to play on that stuff. I don't foresee myself doing anything with these, but if I would yell out to any of you folks, if you even know what one of these is, let me see if I can pull it up on the website real fast. Spark. So yeah, we'll go over to the desktop. So there's the spectacle kit, which I've got some bits and pieces from. I don't have near the audio hookup that I need the little audio cables for doing things. There's some close up. That's basically light board where you're plugging in those neopixels. That's what Adafruit calls them, but there's those WAs 28, whatever 13 kind of thing where it only takes a single pin going through there, and a plus and minus. And it takes these in and outs, so that's how you wire signaling between all of these different boards. And some of them have buttons on them, and some have other things that are going on. And this is what it looks like to code it up on your phone. Let's see if I can run it down here right fast so you can get another picture.
Harold, you're showing your parts bin, not the screen.
Sorry. Why don't you call it up there, man? What am I saying there? Hold on. I'm just not as alert as I need to be, I guess. So there's a whole kit right there. I was unlucky and didn't get that. So since I've got bits and pieces, either I get to invest a bunch of money in some old hardware, or I can find somebody who has the old hardware and wants some more old hardware. There's like one of the boards left. So you come in here for signaling it out to the next board. And this is where you plug in your 3 different NeoPixel, or those WS582 whatever RGB strips in the thing. That's kind of how they all, that's kind of how they walk. So you got an in and out, and now you got some buttons and stuff that they'll take buttons, and then once you do all those button things and start plugging things together, there's also got a servo motor controller too. You'll have all these actions. These are actually running on your phone. Let's see if I can find a better picture here right fast. There's one. So this takes the audio out from your phone, which this shows you how old this is, depending on audio jacks being in your phone, which is not a thing anymore, or becoming increasingly not a thing anyways. And go through the boards, and every one of these boards, if I wanted to look at just any one of them, you can see they do sell them still. Let's see, can I buy more? Buy me. That's hookup guides. And don't say, but if you go and look in these, each one of these little boards is somewhere between, like I say, $10 and $20. If you can even buy them. There's another little hookup thing that you're going. This is the application that you're installing on your Android phone to do stuff with. And it is kind of neat. It's just, it's probably still usable. It's one of these things where I've got so much going on. Do I want to spend time working on something I know I'm never going to do anything with, but just play with once and put in a bin someplace, or go do other things. The other thing I got to whine about on ROS 2 specifically, is it says I'm supposed to fire up. Here's me. It says I'm supposed to fire up. I can. The local bus works. So on the same machine, if I do an example, talker and listener, the listener picks up on the chatter, goes through it. But what I want to do, so I can debug things in control, is have a talker on my robot brain and a listener on my computer, my lab computer, because they're all on the network. That ain't working for crap. Everywhere I go, it's like, here, I've got a tutorial on how to do that. Well, you do this, you do this, you do this, it just works. And I'll go, well, I'll do this, and I'll do this, and this, and don't shit work. So I don't really, I've done a bunch of troubleshooting, because I know it talks over multicast UDP to make their things work and define themselves to do the stuff. I've turned off every firewall on the planet. I've got one hardware thing. I've got a Wi-Fi on the Raspberry Pi. And maybe if I hardwired the Raspberry Pi, which I get, that's the only thing I haven't tried, things will just work. I want to get that stuff working. It's not, because I think it's important, because I'd like to monitor the thing and control it from the lab computer, and then have some smart, be able to. I want the robot to run around freely on its own, but I would like to plug some nodes into the on the lab computer that will hook into that same bus stuff, so I can monitor the bus traffic and do all those sorts of things that can do it. Chris is over there laughing. He's giggling at me. I know.
I'm giggling because I had the same problem literally 15 minutes ago, because I'm fiddling with stuff while I'm listening. Okay. And and I'm just setting up, my Pi with ROS 2, and been spending time installing stuff. And so the thing looks like you looked at most of the things already, but
There's even
have you?
there's a ROS 2 multicast tester tool that you have on your box, and I can that comes as one of the nodes, one of the utilities. That thing works. It says,
Okay.
hey, that thing
So
works.
the thing it turned out to be for me was I had to explicitly make sure, the identifier, the ROS domain ID variable is set to the same value on both, the Pi and my PC. I don't know if it's the case by default, but just make sure you set it, to.
I haven't set that any at all, and the documentation says you don't unless you've got multiple ROS buses on your network. It's supposed to just go to default. Maybe it chooses a different default on every computer or something.
Maybe. So I think just explicitly set it to the same value. That's what I had to do, and then it just worked.
Yeah. Okay. I'll try that. I'll try that next time when I get it. Set in some environment variables so that things. You don't have to set them all, but this one it said you didn't have to set it at all, but it should do work. But I'm like, okay, we will set things. We will start setting those things I'm not supposed to have to set to see if things just work. Yeah. But besides that, things were going along pretty well with that. I mean, I try something, compile it, it works, and up to the point where I was getting adventurous, where I want to make sure that I can have the lab computer monitor and send signals at the robot from afar. That kind of stuff. And see what's going on in there. And and even with the Windows install, I had to reinstall on my Latte Panda the Foxy from the MSIoT guys, the Lou Amadeo folks. That is compared to what I tried to do back in June of last year, it was dead simple. Click, click, wait. Run the Choco stuff. I'd already had some stuff installed, so I didn't have to worry about it. But Choco install. They've got a Choco installation script out there that grabs all the junk for you and puts Foxy desktop on your Windows box ready to go, and says, "Oh, go source these batch files or PS1 files, whichever one you want to run on the thing," and it works. I ran into a couple of things like RQT and the visualizer. Sometimes that QT visualizer is not either not installed in the right place or something a bit weird, but I'm not as concerned with that at the moment, because I think that's more of a helpful tool as opposed to a needed tool. And when I get around to actually needing that, I'll go get that. That's a way to graphically show how nodes are connected and that sort of stuff with GraphViz. So you can see who's talking to who and who depends on to, like what interfaces go into what. And by an interface, meaning the interface describes what a message looks like that a node will accept. So if I take a bunch, like they got one called Twist, which has a vector 3, which is an X, Y, and Z for linear, or an X, Y, and Z for angular. So you can find not only a vector that's an X, Y, and Z integers floating point numbers, you can also give it radians and degrees and that kind of thing to describe any kind of motion you're doing in a weird way and that kind of stuff. And yeah, and some of that I got feedback working. So hey, go from here to there. And I say go from here to there. Do this action, and every so often give me some feedback, and I can monitor the feedback stuff, which is some really cool stuff, and how to set up custom things like that. I thought it was really cool. What did I do? But I thought about that domain ID. I've seen it. And so, Chris, you're telling me that I probably should just set that up by
you got to eliminate all the variables. I don't know if it does the trick for you, but it did the trick for me.
It's according to all the documentation and on their source code and all, it's not supposed to matter if you only have one thing broadcasting, or you're only broadcasting one mesh of nodes, if you want to call it that. I'm not sure what you call a group of nodes together on the thing, but if you're only talking on the same, I believe DDS bus is what they're DDS is what they use on there. But I will give that a try. I will give that a try.
I have a question for you. So I know you're into the Windows side of things. So you're running Windows everywhere, or just on your PC, or also on your robot? You said, right, on the Latte Panda. Okay. So everything is Windows. Everything is in Windows on your end, even on the side where you're visualizing the data. You're running RAWs on the Windows PC, and you're running RAWs on the Latte Panda.
Yeah. I do have another Raspberry Pi 4 over here that I'm going to use for other talks and stuff, and I do have a version of ROS on that. I just haven't. I couldn't get all this stuff talking, so I'm like, okay, let's make the two Windows things talk, and then I'll make the Linux talk on this thing. Just proof of concept, to make sure it's supposed to be able to do this, and I would like to take advantage of it. So let's make sure I can do this before I make it too complicated. And because I've got another talk, I've got to. In fact, I've got to write an abstract for and put that in there. I meant to do that. I haven't. I don't know when I'm going to do it. But abstracts are hard for talks. It's talking about doing .NET 5 development on a Raspberry Pi. So I've got my talking head, which I don't have powered up at the moment, has a service on it, and it's all .NET 5. Talking to the GPIO, flashing lights, taking buttons in and making actions happen, and it's running on top of Linux on a thing doing it. It's pretty cool. I'm like, is that going to
mono or what?
What now? No.
Or how are you doing?
.NET 5 is now .NET 5. It used to be .NET 3.1 core or whatever, but no, .NET 5 straight up. Is available for ARM processors as well as other x86 processors on it, and you can get on there if you will use the command line tools to make all your stuff happen. So the word .NET space new space console and give it a name and hit return once you've got it installed, and it'll suck all the stuff down you need, unpack it, and so you'll have a Visual Studio project built on it. And you can go in there, you get a program.cs in there and go whack on it. And you go run it, and you're running .NET. And in this case, the head does a service. So it spawns off a daemon in Linux at startup, like any other Linux service that you've ever wanted to ever do in Unix. Window, that kind of stuff. Fires it up, works underneath of it, and listens to my GPIO for button presses. And
cool.
Then applications to do that, yeah. And it works surprisingly well. What I haven't figured out yet, which I need to figure out for the talk, is a good debugging strategy on this, because I've got it running on the Raspberry Pi, but I would like to hit a breakpoint at some point in that and have the Pi break there, and there's a debugger that you install and run as a service on a Linux box. It handles that for you, but it requires some more setup on it. Like when you hit like the Control-Shift-S to build everything, and that one of the build steps needs to deploy that bit of code to a share file. That's how it works now, and I think there's better ways to do that. And so when you hit the F5 key, and this is all for all of you guys don't play Visual Studio, just says go run it in debugging mode. I've got some properties set up that, yes, you're going to run it in debugging mode, but you're using a remote debugger at this IP address, and that debugger knows how to go and fire up your program and do all your debugging stuff and feed you back information.
Yeah.
Yeah, it's pretty cool, man. I thought it was really cool.
Interesting to know. Sorry to talk Microsoft.
No. I'm a Microsoft MVP. You want to ask me some Microsoft questions, I'm always happy to answer that crap, regardless. But I had my ROS 2 complaint and a little show off, which is about, I think I've showed off today. So I still got some more stuff coming from China. Hopefully it'll be here in the next week or two. That kind of stuff.
Cool.
Yeah.
All right. Doug has a mug. David has a mug. David, are you putting this up for a reason? Yes. You're on mute. He's talking head. Okay. All right, that's what David's got to show. David's frozen. Oh, look, Chris got. I'm thinking we're seeing prizes from the contest here.
Yeah.
Very nice. Yes, I'm glad that it arrived. There are some more that need to be put in the mail yet, but a certain club president, I mean, I wouldn't say re-elect him, but a certain club president still has to swing by the makerspace to pick things up and put them in the mail. So haven't forgotten. Haven't done it yet. But Doug, that Doug guy's on top of it. He got that part sent. And the
I'd say re-elect me because you can't get anybody else to do the job.
yeah.
Oh,
All right.
I do have
yep.
I do
Comments
have a
like that'll
follow-
get you on the roster. You know.
I do have a follow-on whine to follow up from Harold.
Go for it.
Can I just, okay. So my wife got this cordless vacuum cleaner for Christmas. And the first day she's using it, it wound up a bunch of monofilament line around the, so yeah, tight as a drum. And so there wasn't an obvious way to get the thing apart. I downloaded the owner's manual, which didn't mention anything about trying to get the roller used. And it turns out the whole thing was held together by these little tiny Torx screws. So, you know, I rounded up a Torx set and it didn't work. And so I had to learn a little bit more. And what I learned was, well, I'm going to show you. I don't know if you can see these or not. This is the kind of Torx screw that was in it. These are Torx security screws.
Oh, those are
Anybody know what
security.
that is?
Security.
Oh yeah.
Basically, it's got a
little
little
bump in the
dimple in the middle of it so that you can't put your damn Torx screw in it and loosen it. So I managed to get the thing apart by breaking a small screwdriver and regrinding it. But I couldn't put it together because I couldn't put enough torque on. So I actually had to break down. Now I'm the proud owner of
Security bit set.
this complete set of these obnoxious Torx security screws. Who thought of this? Who thought this was a good idea? We bought this thing. It's ours. Who thought it was a good idea to make it hard to take apart? Okay, that's all I have.
Hey, Harbor Freight has a, I'll pull up here in a minute, but Harbor Freight has a really nice kit of a lot of small gears like that. If you haven't seen them, a little bits and things.
Yeah, it has all the weird ones.
Someone else talk.
I think those Torx screws were designed for public bathrooms.
Well, you know, when you have small screws, if you really have to put a lot of torque on them, it's very difficult to do that with a flat blade or even an Allen wrench. The Torx really are better if you really need to drive something with high torque, especially for small screws.
Do you see that? Do you see that yellow patch on the back? There is a TV mount. It didn't get painted for the exact same reason.
Is that right?
Yes, that is right.
You know, and,
Well-
and there's Phillips screws too, right? And they're not really good for torquing on anything. And then you got, I'm a real big fan of the square drive screws from McFeely's. And I can put a lot of torque on those things and I can, yeah, they hold really well and not even making ties there. Yeah, I'm a big fan of those.
I didn't end up buying torque, but you can buy these bits and they, bit sets. And this is like a torque bit set. They have both the hollow point ones and the ones without the dot in the middle. But I didn't buy whole screwdrivers. I just bought a set of these.
Yeah, those are
Well,
secure.
that's basically what I have. The one I needed for this was a T8, which was the smallest one in my set.
Mm.
And also to follow on, I also have one of these deburring tools. Harold, this is to make you jealous. See the beautiful brass
Willis, you got a nice.
knurled handle, press button release there quickly.
Can you put the excess blades?
David's always one upping me, and that's okay.
And they're just sharp. If you haven't used one, that they have a ground edge on them. That's what the extra SETI has. And the reason they rotate is so that you can clean out like a hole if you had a hole in that you dug or something like that. But these can actually carve aluminum. They can carve steel. It's quite impressive.
Oh yeah.
and it makes a really nice. You know, if you, like I say, you want it just easing that edge sometimes where you need it in a nice round circular thing. It's a really good tool for doing that.
Versus getting cut or getting a sliver off of it.
Yeah.
You mean these?
Yeah.
Yep.
Oh yeah.
All right.
Let's see if I can.
So, all right. So moving on. Who else has show and tells or wines or things like that that we should talk about tonight?
Okay. I found this one in the middle of my road. It's a very nice set. I really didn't take much effort to find out who owned it. So
I was going to say the middle of your road. What truck did you pull it off of? As it was parked in your driveway.
yeah, that's the old Italian thing. It fell off the back of the truck.
You exhausted 2 seconds to try to find the owner?
Anyway, no, seriously, it wasn't the center of my road. Some ranch hand dropped.
Has it really been that quiet of a holiday season? Has everyone been so busy opening presents and celebrating the world's most quiet ball falling in New York Times Square?
Yeah.
Carl, my partner and I went up the east coast of New Zealand, which is supposed to be hot. Like Napier is supposed to be hot for New Zealand, like 30 degrees, which is like, 90. And I was there 10 years ago and it rained on me. And guess what happened this time?
It rained.
Yeah.
Excellent.
Normally hot, it was raining. And I actually had taken this box full of raspberry pie and stuff, and I never opened it once. So that's a good holiday, I think.
There you go.
Yeah.
Well, that's cool.
Well, and since I'm chatting, I'll just continue.
Can y'all hear me?
Yeah.
I've been trying to get my mic to work all night, so I finally got it.
Welcome.
So I'd like to show something when y'all get ready. I got a presentation.
Well, cool.
Go, Mike. Go, Mike.
Remember
let's
that?
Have Murray finish his thought. Let's have Murray finish his thought, Michael, and then you can
Yeah,
take on.
yeah, go ahead. I was just testing. So
okay.
Go ahead, Michael, if you're ready.
no, y'all go ahead. Let me get me set.
All right, I'll be really polite and just interject. All I was
Let
going to say is that, as many of you know, I've been working on software for so long that I'm getting bored with software, and I really wanted to get back into hardware. So I'm just starting on this new design, and I've got this design in my head for a lightweight Mecanum robot versus a differential robot, and I think I know what David would recommend. So what I'm trying to figure out is, like, I've got basically the same gear train as my current robot, which is 2 of these 12-volt, 9-volt motors, all geared up with encoders and everything. And this is the same drive mechanism I use on my bigger robot. And then I'm probably I could use this as a differential drive rather than these nice little Mecanums. But I don't know. I'm kind of up in the air, Carl, this whole Mecanum thing. Yeah, I know. It's like I know the intelligence of a differential drive robot. It's the thing to do because it, even on the little one that I've already built, it just turns nicely in a smooth circle. I've seen David's, go around his office smoothly. And of course, a 4-wheel robot of any kind is always kind of chugging around corners and all that. And I'm just thinking, what's my next experience going to be? And I don't know. But I'll leave it at that. I don't really have a progress report. Just letting you know, I'm just jumping back into hardware now and trying to figure out what the next bot's going to look like. So, Michael, are you ready yet? Oh, you're on mute.
Yes, I'm ready.
Kevin. Bye, Kevin.
Hi. I guess some of y'all know that I've been working on that claw machine for a long time. I finally got it and took it to a Halloween carnival, and I'd like to show y'all just a video clip of that. Now, when I do a presentation, does it do a screen capture? Is that how that works?
Yeah. Well, when you present it kind of makes sure that it owns our screens, and then your voice comes across as you talk anyhow. So presenting should work well.
You won't see us, Mike. You won't see us.
Okay.
We'll be looking at your screen. So whatever you want to show, put it on your screen.
Okay, what I'm going to do is I can go ahead and run a YouTube clip, right?
Right. Just have YouTube and
do full
present.
screen. Okay, here goes. Now this is entire screen. Y'all see that?
Not yet.
Face masks and
Full screen. You see that lady in the green shirt?
No, you should need,
You're not presenting yet.
on the lower right corner, you need to go to the button that says present now. Present which screen?
Present
Lower right
now.
corner.
No, it's bottom right. Bottom right.
Entire screen. Allow.
That sounds good.
Is that it?
There you go.
Yeah.
There you go. Now we're going.
Okay. Let me turn it. What is it looking like?
We see YouTube, and you just made it full screen.
Is it full screen now?
You hit the home button.
Yeah. Yes.
There you go.
I think somebody's
Okay, I'm
cheating.
fixing to present. This is at our church Halloween carnival this year, and so y'all can see this.
Yes.
Okay, here goes. This is a guy. That's my wife there. This is a guy fixing to pick something up, and it won't be but about 30 seconds. He's going to grab him, I think, a matchbook car. And so there we go.
Very nice.
It worked. It picked something up.
It works. Pick something up, and I'm gonna work on that claw some. But that's my first prime time on that. So anyway, there we go.
I'm impressed. Very good.
Yeah.
Very good.
And it does
Thank
it with style and grace, and it looks good.
Thank you. I worked a long time on that off and on, through heart conditions and everything else. But there we go. It finally went to all the kids loved it. They had a blast, and I got a kick out of it. And that ain't where I'm stopping. My next one's going to be, I'm going to make a robot arm kind of like a crane that goes at 180 degrees around. And they can pick it up. It'll still have the string that drops the claw, but it'll be they won't have all that controller on the top. Did y'all see any of that at the top? I'm using a tote to put all the electronics in it. It's running on a Mega Arduino, and stepper motors. I'm using stepper motors to drive all the axes on it. So, but my next one's going to be just it'll be easier to carry from event to event. So that's what I wanted to present tonight. So,
Cool.
Very nice. Very nice.
there we go. Hey, I just wanted to share this with you. I don't get on Tuesday nights because of work a lot of times, but right now, I mean, before you get alarmed, I'm at home on COVID quarantine. I don't have COVID, but I had some sniffles. Y'all don't touch the screen. I had some sniffles and running a little fever, so they don't let you come to work like that where I work. So I was able to sit in on Tuesday night, so that's why I'm here.
Day off, just sneeze a little, right?
There you go. All right. Thanks, guys.
Hopefully you don't have it for real. It's just to watch. So good luck.
I don't. I've already took the test and it came back negative, but I still got to stay out so many days. It's all policy. My company policy. So that's it. That's what I've been doing, robot. And my next one, like I said, is going to be a robot arm. The same kind of thing. And hopefully maybe by this year, by next Halloween, all this COVID stuff will definitely be over with and or at least under control, and we can get back together and things like that.
Carl, I have a question. Is anybody here in this gathering tonight working on a sumo for a virtual sumo contest?
new?
That's a great question. But yeah, I'm not hearing anybody speak up about that because
Yeah,
we do
we
have that
don't.
invitation. I plan to attend to observe anyhow for
Me too.
Seattle Robotics Society coming up a week after our meeting.
Mhm. Yeah, I don't. We haven't had a real strong sumo for adults, at least. We had it with the kids where they did the plastic sumo, but for us, there wasn't that many. Not that many of us have sumo robots.
Scott was the most active, and we haven't heard
Well,
of him since
actually,
COVID.
yeah. Who's the guy that always
Scott,
wins?
Scott.
Yeah, Scott.
We haven't heard of him since March, I'd say, pretty much.
Yeah, he has a nice robot, my understanding. And I also think Kareem has, because they used to use them as demos or when they were doing other activities. So they had some sumo robots.
Yeah, besides Kareem, I don't. Does anybody else in the club have one?
Right now, I don't think. Well, they might have the base. I mean, I know a lot of people have Zumos, but nobody has them set up as
Sumo wrestling Zumo?
yeah, right. Yeah, then nobody has it set up that way.
Yeah.
Donna, I think you're muted.
You're
Well,
muted.
oh, no. Donna, you're not muted, but your microphone's not working.
That's promising.
Yeah.
We caught a sneeze.
He's just not saying anything. No.
I see David moving his lips. Okay.
But
I'm only
not really
seeing 9 images in this Hollywood Square. I can't see all 15 people. So
Yeah, just slide it over. There's a slider on the presentation, and you can bring it up to 20. Well, you actually bring it up higher, but Carl, if you just slide the slider over, you can see more people.
the slider's hiding from me.
It's in the
Oh, the change layout. There it is.
Yeah, you can change layout and then slide to get more people.
Okay, I've got it now. All right. Well, okay. So swinging around the table.
Well, yeah, Donna's.
Donna,
Does she know we can't hear her? Hands up or hands down?
Yeah, Donna, if you're intending us to hear you, all we see is your head moving around your face and waving. No luck on the microphone tonight. Yeah.
I did have a question. We talked last week with Jesse about the idea of these sumo tanks, and that was something that's really appealing to me. So I don't want to steal Jesse's thunder or sort of subvert what he's trying to do, but I've been trying to figure out how to build some kind of an attachment that could fit on top of a standard sumo, like those little Zumo ones from Pololu. A standard attachment that would have, let's say, side IRs, a back IR, and a front IR transmitter, and then some kind of a controller that couldn't be subverted by the user's program. In other words, maybe just hardware only. And in other words, something you could attach to the top of the robot that would be triggerable by other tanks. You'd have to know possibly who did the shooting, maybe not if it's only 2 tanks, but you'd want to be able to make it so you don't shoot yourself. All those things we talked about, but it's quite a tricky problem. And I was kind of hoping I'd see Jesse this time, but it'd be nice to figure out if there's some way to build out something like that, maybe prototype it. It can't be just some simple TTL thing with IR. It's got to have the ability to figure out who's doing the sending so you don't shoot yourself. And some of those IR sensors have the ability to send numbers. So let's say you'd shoot a number 2 and the number 3 would be ignored or something like that.
Yeah, they're modulated. Pololu has a sensor. I'll see if I can look it up. It's not super cheap, but it was made for this type of contest.
Oh, okay. Yeah, because there's one from Adafruit that's just a 3-wire IR detector that has a little chip in it, and it can actually decode the number that it's receiving at 37 kilohertz or whatever it is. They're quite, it sounds like actually kind of a tricky hardware problem unless you want to build it out as a little, like an Arduino or something on its own.
Murray, are you thinking like when in the days of laser tag, you would just go in as a person and strap on a vest? Same,
Yeah,
except in robot land, you just strap on a little laser tag thing on top of your robot.
Yeah, exactly. It has to be something that can't be programmable. Otherwise, you could theoretically deprogram the thing so you would never get hit. So it has to be something that you could attach to the top of the Sumo. I've got kind of a set of requirements in my head, and they're quite simple. You have to be able to trigger the firing, either that or it fires all the time. You have to have a counter to know how many times you've been hit on the sides or the back, and you can only receive the other tank's messages. You can't receive your own. So those are sort of the requirements. And then this would be something that we just plug on the top of a Zumo, and then there might be, let's say, LEDs or maybe just one LED or maybe a counter on the top, so you could see these two tanks firing at each other. And then once one of the tanks has been hit 3 times or whatever, it would turn red and that game would be over. But something like that. So I've been kind of tooling around in my head on some kind of hardware that might be able to do that.
You could use
It'd be for a club robot thing. What's that?
TV remotes, do basically the same thing. It's a 40 kilohertz signal, and then they modulate that signal. So there might be something that could be exploited there. Or better yet, the tanks could drive around turning off television.
Turning off what?
The tanks could drive around turning off television.
Yeah.
Yay!
Murray, I just sent a link out in the chat. I believe this is kind of like they have a couple of products, but I think this one is similar to what you're looking at.
Like one of these little guys?
No, it's take a look at Pololu product number 702.
Okay. Yeah, this is a little, I think it's about $10 or maybe not even that expensive, just a little IR remote. I could take this apart, probably maybe trigger it somehow. And then what you would do is when you start a tank contest, you just make sure you're not firing on the same number. But apparently this is a problem to be solved. No one's done this already.
You could commercialize it.
Well, like I said, I don't want to, if Jesse's actually in the process of trying to figure out how to commercialize what he's doing, I really don't want to come up with a way to like go to Pololu and say, hey, look, here's an idea. And then they go and put it out there and just totally screw Jesse.
Well, there's actually been a robot made came out of South Africa about 10 years ago that did this. Plus it did some other things. It actually had RF tags that you could pick up off the floor if you ran over them, and it had beacons that if you shot at the beacon and hit it, there was a whole bunch of different things. And it was geared to be teleop, and though it could run autonomous also, and it was used actually in leagues down there, similar to Vex or Lego contests. I actually got one from an old member, and they are quite ingenious and an awful lot of the way they handle the IR stuff. But if you look at that it's not cheap, but if you look at that Pololu product, it's actually got 2, so you could make 2 robots. And I believe it's made, I think one of the things is they have one robot follow the other robot. That was one of the things that it was supposed to do. But
well, I know that on
Carl, Doug, you remember the old MIT 6270 robots had a beacon on them that broadcast at 40 kilohertz, and then you had a switch to choose whether that was modulated by, I think it was 100 hertz or 110 hertz. And so the 2 robots that went head to head, one was 110 and one was 100. And
Yeah,
that's how
this
they
one might be, yeah.
ignore
So that's not-
themselves. And, especially if you're using the IR for avoidance or something, you don't want to be tricked by the other guy's IR. So,
Mhm.
and that was just a real simple modulation. They had a little software phase lock loop running on each computer that could lock into your particular frequency.
Yeah,
So
it
that's
was-
kind of the same.
Yeah, one of the tricks of this one that was from South Africa was it's really pretty hard when you're trying to simulate a gun, otherwise you're simulating something that's going out, but only in a single direction.
Mhm.
And there was several tricks that they did, like the one that was actually detected that if you were pointing at the sensor, it had some that were surrounded so that it would angle towards it, but when you were straight at it, there was this one sensor that was set back way in a hollow notch, and that one would see it and shoot up, would flash the lights,
Yeah.
So it's pretty, it's like Murray said, it's not trivial, and it apparently isn't cheap, because if you look at those Pololu modules, I think they're about $28 a pop.
No, it's
So-
it's a pair of them is $50.
Yeah. So anyway,
But I looked on the Adafruit Learn site, which is their learning and examples and stuff. And there's actually a couple examples of these kinds of things on their learning site. But this actually, it's still not cheap, but two of them for $50, that's 25 a piece. That's about $33 New Zealand. That's not prohibitive. If two people wanted to play, and in fact, if the club owned these things and they could just be placed on top of the robot with some kind of a plug onto the Zumo, it might be that anybody could then program their Zumo, and then these things, we'd only have to have two of them for the whole club, kind of thing.
that's a great idea, Marie. I could see where you could have like a standard plug, and you just pick it off and put it on the next robot. And
Yep.
That's a good idea.
Yeah, I think that's kind of my favorite so far. Thanks, Doug, because I think that if I could buy a pair of these things and try them out and figure out how to get it so that the sensors, so that the transmitter goes through a little aluminum tube or something like the way Jesse was talking about, and then the sensors are set in a certain way, and then the club basically owns those things, and then, like I said, the standard plug would be power, ground, and something to trigger and something to count or something like that.
Maybe I2C,
Yeah, something like that. So this looks good. I'll look at that. Thanks. And that's it from me. But we've got people who have not talked yet, so I'll start up.
Hey, I can share something if it is the right time.
You're up. Go, John.
All right. Yeah, last week I was really taking a lot of your time, so I want to follow up. Let me share my screen here. So yeah, whenever you guys see my screen, please let me know.
I see it.
Yep.
Okay. So yeah, last week I was telling you guys I can't I find I can't drive my motor consistently. So, and then I had this concept that it's the PWM frequency. Well, it turns out I think so basically I talked to you guys, and then later I think maybe Ray, was it you? So I thought maybe my ground was a problem. But then anyway, maybe it's a common sense, but I did not. I have a battery powering my motor, and I have a computer powering my Arduino, and they were not sharing the common ground. So
Are you plotting velocity versus PWM or what?
I'm sorry.
Are you plotting velocity versus?
Oh yeah. This is okay. I'll come to the picture here. So then I basically went off and just made a board, have a breadboard just to test one one channel, one PWM channel, and one motor. And so then I was looking at whether the PWM frequency matters. So this is basically, I have one medium power motor from Pololo, and I had the Arduino I have, it's this Mega. It doesn't have many choice on the frequency. It's like either 32 kilohertz or 4 kilohertz, or that default value. So then it's interesting. What I did, because I can remember I was writing this C# on the host, and I can talk to the motor. So I just wrote a program that I click a button, it'll step through, it'll measure the speed out of the encoder, basically dividing the time and get a speed out of it. So what you see here is the different, I mean, let me see, show you. So you see the different frequency. Yeah, there's some difference. There is some difference. And looks like this 32 kilohertz is a good choice. It's pretty linear.
Yeah, that one would be the choice I would go with.
Yeah.
Looking at that.
It is very quiet. I think the other thing I realized is I was looking up these code to change the PWM frequency. Well, at least that page I used didn't really work. So it's like, anyway, it's saying, okay, this line changes the like pin 5, pin something, and then it didn't change because I measure it off my oscilloscope. I see, oh, it didn't change.
Okay.
But yeah, it's interesting.
Looking at is talking about the Mega and not the Uno, because they have different ways of controlling frequency.
Yeah, well, you just basically have to change it back on register.
Yeah, I mean, one thing I realized is, oh, it's saying one line changes pin 0 pin, another command changes another 0 pin, and they're exactly the same. So I was like, okay, that's
look at the link I put in the chat.
Oh, the link I have, yeah, I can get that. Okay, I'll get that.
I was just playing with that link, and I'm not sure it's working, but it looked like it did.
Yeah, but just to show how.
John, what are the vertical lines that were dropping from the waveforms down to the 0 axis?
Oh, sorry. How to change? Yeah, this is the one I used. Okay, yeah, going back to here. Let's see.
Not a real line.
Not sure. Let me make sure I'm not sure if. Yeah, this looks like. Let's see, Mega.
That's not the page I sent the link to.
Okay, I was Googling this. So, yeah, possibly. I mean, yeah, sorry, I just Googled it and I used the information here. And
well, you can see there that they're changing a couple of registers, and they're saying this routine actually allows you to choose several different frequencies.
Yeah, I can show you my code.
Different registers control different pins.
Right.
I can show you my code where I did the change.
Probably also functions of a timer.
I believe you're right, Ray.
So yeah, so later I figured out these are the lines. Well, anyway, I figured out I can change the pins. I think pin 11 doesn't work. So yes, I mean I later chose I need 4 pin, and I got the 4 pin. So I think I'm happy now. But yeah, there was some catch. I think it's a good thing that I have an individual channel and verify with oscilloscope.
Okay, so there was a question, Gene. why do you have the weird points that go, like it looks like it goes from the curve down to the 0?
Oh yeah. So this is one thing I want to ask you. I have several motors. The two motor have these medium power and high power motor from Pololo. This is the LSD value I drive the PWM, right?
Yes, yeah, got that.
So when this is basically, there's a hysteresis here. I drive and it wouldn't do anything. I mean, if it's low frequency, I'll hear the sound that it's just like
So there are two
trying to
different
drive
motors.
it, but it doesn't move
So it's two
until
different
it
motors.
reaches 100 plus.
Wow.
The other motor I have is like 30 or 50 something that it goes up. That one is like a cheap motor from Amazon. But maybe I can show you these. But you see, this is 4 motors. I have 4 motors, high power motor. They all behave similarly, right? They all have this hysteresis.
So once you got them moving,
Wait a minute. I want to make sure we're using the right term. When you say hysteresis, that means that when you go up in value, it follows one curve, and when you go down in values, it changes a curve. Is that what that's what you mean? It's not. Yeah. So you're telling me that, say that one of those motors there was all the way to 150, but when it came back down, it was all the way to 30?
Yeah, it'll keep moving. But I mean, you guys don't see this?
Well,
John, I have seen that before. If I understand what you're describing, which is that as you increase the PWM, the motor doesn't turn, and then it suddenly jumps on. But then as you decrease the PWM, it will run slower than when it started. I have seen that before, but I have to tell you that I associate that with using too low a PWM frequency. And since you're using 32 kilohertz here, which is what I use, I don't see that phenomena.
Wow.
Interesting. Okay. Wow. Well, so you basically, it's repeatable, going like starting and ending. Wow, that's.
I have a curve that I just did right before the meeting of one of these little yellow motors, and I was amazed because I was testing out what David had told me about sine magnitude, and it was just using the default frequency, whatever it is. I can't even, it's either 490, I guess, or 720, I think. And it was very linear. If you stop presenting, I'll just show it real quick, and then you can talk about it. Okay, I can't get down there. Come on, up, here we go. Okay, this is the curve from negative to positive at 50 milli, I was just doing 50, and it was very, 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 very surprisingly linear and surprisingly matched forward and reverse. Now this is no load, so all bets off when you put it on load, but the last point I had was this 50. And so anything in this range right here, I can't guarantee that the motor would turn. So they made but at 50 it was turning. All right, so this area down here probably was not turning. But that's just showing you how different motors are different. Stop sharing.
Yeah, that's great. I don't know what else is in my loop here.
Oh,
I haven't really.
So that locked antiphase?
No, that was let me ask you, okay, Dave, you sure that's called sine magnitude? The reason why I'm saying is because it looks like, if you look at the data sheet, it looks like it's going from full forward to full, oh, excuse me. It's doing forward and reverse, depending on the state of the PWM. So it's always either doing forward or reverse, okay? And when you bring it to 0, it'll stop, okay? Now, as you would expect, one of the directions has to be inverted, or otherwise, let me show that again. This is probably all little hats, so I don't know if it's worth it, but okay. Now this is just a simplistic motor test, guys. Don't judge me. All right. So here you can see I'm just setting a left motor speed, and here I was testing to see what happens when you don't set the other speed. All right. So I have a set motors versus set right motor speed, which uses those two. So that's just a different function in it. But if you look at it, you'll see, so how this works is it sets a direction equal to 0, which is the forward. If the speed is less than 0, it changes the direction value to 1. If the speed is equal to 0, it sets the direction equal to 2. That is not really necessary, but it's sort of a belt and suspenders. And when it goes forward, you notice, because if you think about it, one of the directions, it's the number, it's the amount that's on versus the amount that's off. And because you have 2 pins, one of them has to start high and the other one has to start low. One of them you have to start with 250 and subtract the speed number. All right. And that's it. That little routine right there is the whole ball of wax. Now this is Arduino, and I'm taking advantage of their analog right. You know, if you were going to write the PWM code for a non-Arduino, it's a little more complicated, but not much. So anyway, that's all that's going on. And you notice there's only 2 pins being set. The enable pin is tied with the jumper for the Dave's instructions. It's just tied with the jumper. So like I said, it was most like how linear it was.
Magnitude. That looks like you're running sine magnitude.
Yeah. Well, that's what I was.
Does that look like to you?
Well, I took your word for it. I didn't really investigate that per se, but I was looking at the data sheet and using the conditions here. And like I say, I know you can't see that, and I don't know if I have it up.
You're still presenting.
There's a little easier way of doing that, though, is that if you use a essentially a 9-bit value.
Yeah, you just use an integer. Yeah.
Right. Use an integer. Use the most significant bit is your direction pin.
Yeah.
And the next 8 bits down goes to your PWM. So that you don't have to have any case or anything like that. It's just how you split the bit.
You have to write in Arduino that wouldn't work. Yeah, because you're at least not with the analog right, it wouldn't work because you have a max value 250, 255.
Right. No, but what I'm saying is that you mask off so that you have the next lower 8 bits.
Right. Yeah, I hear you.
You send those 8 bits to the PWM. You send the sign bit to the direction pin.
Yeah, I'm hearing you. But I don't see that being easier.
Statements or ifs or anything like that. You just run the value from being positive to negative, and it handles it.
Dave, could you show that? I mean, because I'm not seeing it. I mean, I'm not saying you can't do it that way. It makes sense, but it seems to me you would have to translate. You still run into the problem. Oh well, okay, no, you're right, because the negative number will be inverted. So like if you do zero, a negative zero, it'll actually be
Maximum negative.
255. Where if you do a positive number, a zero would be obviously no bits. So it's probably easier to think of it with one, say one, versus one forward and one backwards. That way you don't have a zero. It would be all ones except the bottom one, and then which would be a zero, and on the other one it would be all zeros but the bottom one.
Ones.
Yeah, that would work.
Smallest value going negative.
Yeah, that would work. I'll play with that. But this one is easier for people to understand and see. You got to remember, I'm looking at it as a training opportunity. But I understand. I wrote down what you said, and I understand it. And that would get rid of the having to subtract from 255 in the negative.
Just automatically takes care of itself.
Yeah, but like when I look at that, what you're seeing is, like you say, you're just switching back and forth between forward and reverse, and it's just the ratio.
Well, right, it's a continuous from full reverse to full forward.
Yeah.
And as it goes through zero, then you have the pin being low, your direction pin being low, and the PWM all zero.
Yeah, it'll be both. Yeah, they'll both be low.
Okay.
Yeah.
And then as you increment it, you'll see that indeed that the direction pin is low and the PWM is increasing. Okay. Then as you go down, as you go through zero, you get to all one. Okay. Yeah. Now the all one has switched your direction pin, but you're now having the
I see that.
Full, and so it's essentially going the opposite direction.
Yeah, I see that. I understand. And I'll write a routine to do that too. But I just wanted first to see if I was going to blow up my 298, and it didn't. It worked great, and it was very linear, which I'd like to try on a Polo Loop motor next to see if it still maintains that. It'd be interesting to connect it both ways and see if the response is at a given PWM, if the response is more linear or non-linear. Anyway,
John, I
can post my motor model. It's strange. My motor just behaves differently. Maybe my circuit is. Yeah, I don't know.
I would think that the high-powered one would behave differently than the low-powered one.
John, I would
mention that. Different. Sorry, Dave, go ahead.
In industry, on a very
I would just
drive, we get around that by when you start the motor, you inject a high amount of torque in a AC motor. That's by increasing amps. So we'll inject DC into a motor to magnetize the motor to get it to go before it spins. On a small DC motor like that with pulse width modulation, you could, when you want to make the motor go in a direction, you could give it a pulse at 255 for a few milliseconds, 10 milliseconds or something, to magnetize the core, and then lower run to your other frequency.
Yeah. I do that. So I have a little. So basically, I drive. I mean, basically, if I see the drive speed or the power is lower than my characterized value, I will drive like a certain threshold, and when I see the encoder moving, I'll stop that drive.
Now, just wait, John. Before you leap too far in that direction, I want to point out that that's what a proportional speed controller will do for you.
Yeah, that's right.
PID controller will linearize that unlinear motor response. So it'll ramp up whatever voltage is needed to get it to start turning, and then it'll back way off on that voltage to get it to continue to turn. It will do that for you. That's in point of fact one of the things that the PID controller does.
Yeah,
It
I agree with that.
linearizes
Got
the
it.
motor response because you're now requesting your motor control in terms of velocity rather than in terms of power.
Yeah, I see.
The PID controller chooses power.
Realize that. No, okay, yeah. So by the way, so this is I figured out I can drive one motor as properly, and then I put 4 motors together. And the left one is I was like different motor but drive to the same channel, and then they look similar. Then I just hooked up the 4 motor to individual channels, and I can drive it together. So it's still on the right. The one on the right is measured simultaneously. It's still looking good. But then I mean, so I think my motor is moving now. During during the process, I was realizing I use these wires. I use these JST. So this is one picture of my crimped wire. So, but you see, I mean, basically, I realized one wire wasn't driving, like it wasn't touching. And then I looked at, this is the one on the right is from internet. It makes sense that when they crimp the wire, it's like grabbing the wire. But you see, the crimp tool I have is just not really grabbing it, but more like just wrapping it. And my wire was thin. So
John, we talked about this a couple weeks ago, I think, is like what I was doing is I just pre-tin the wire, and then all I've got to do once it's crimped is just heat the thing up and it'll just melt inside the connector.
good idea. Print it. Okay. Nice. So,
Yeah,
so
'cause
I should point out,
it's unreliable just having crimps.
yeah,
nice.
I should point out though,
Make it a
that
ball at the
they
beginning.
will tell
Yeah.
you that soldering a crimp connection makes a weak spot. I'm not saying don't do it. I'm just saying if you look up recommendations, they'll tell you not to use solder.
Really?
Because, yeah, because
At this time, what I did is
What it does is it makes it brittle.
yeah.
Well, it makes it brittle, and then part of the crimp, like you can see, part of the crimp is designed for electrical connection, and part of it is designed for strain relief. So when you're soldering, you're like working around the design of the connector, and that's what you see there, John, is the proper crimp tool on the right off the web. It's grabbed those little flanges and bent them in to go in contact in a specific way. Whereas it looks like you might have the wrong tool for that connector or the wrong wire or got the wrong combination of parts, which is why it wraps around like it does. I mean, they make dozens and dozens and dozens of crimp tools for different crimp connectors. And I mean, they're all specially made and closely matched. There's some variation. I mean, some of them that you can use across different types, but
I was Googling that. Yeah, there's some expensive tools.
yeah.
So,
Yeah,
at this time,
I don't know.
David Ackley has an image there. If you want to look at his, he's got.
See, if you look at the well there, it's got sort of a tip in it, and that causes that the crimp right at your zero in your picture.
Again, this is the case
mine
where
doesn't have that little.
yeah, this is where you can go wrong.
How much IO crimp tools?
Well,
probably $30.
Well, you have a special crimping tool now. Radio Shack happened to have these, I think, for about $10 or something ridiculous like this. But they go all the way up to, I don't know, $60 or $100, but the cheap ones.
Yeah, but I want to say this: if they don't have what David is talking about, if they don't have that little, it looks sort of like a little point, like sort of like this. If it doesn't have this part, you're kind of
Yeah,
tool is not going to work very well.
yeah.
You
if
got to
it-
have the little. You got to have the little piece in the middle that
Right.
folds them in.
that
Uh,
curls them over to get the effect right where your 0 is on your picture.
And I'll also say, the one that you got from the internet is a female connector, and the one on the left is a male connector. And my experience has been that those male connectors are really, they tend to be loose and they tend to break off. So I always prefer to use a female connector onto a male stud, or a male header pin.
Male poke.
As opposed to a female header with the male pin end. Because now you say, well, what is Arduino? Well, Arduino is all female headers, but using that type of pin is asking for it. You got to figure out how to get to a female header, and the easiest way to do that is with one of the breakout boards that go on top of the Arduino, because they'll all be female, all be male, all male headers, and then you just put in a female jumper.
I see. Yeah,
But also that
gonna
wire
ask
could
you
be
guys.
also a little bit low current. Excuse me, a little bit low, a little bit small for your high-powered polo motor. Because your high-powered polo motors, I think they have like 6 or 9 amps that they can pull.
Those
So you
motors
don't want to,
with
you don't want to be doing that, but I'm saying they could.
those motors came with such a connector, something like this type of connector, right?
Yeah.
Yeah. I
But,
don't know.
but the size of the wire in the polo connector is probably bigger than, like, if you go to buy the jumpers from China, they use the smallest wire possible. And so you have to be careful about that to keep continuity of your wire, because obviously the smallest wire is going to limit your current by having the highest resistance.
Well, you don't want to use those. You don't want to use those kind of connectors for motor power anyway. You need something like a Dean's connector, something low resistance. Those are for signals.
For a small motor, you can get away with it, David. But I agree.
I wouldn't recommend. I really wouldn't.
I'm thinking initially I like this type of wire because I can just verify it before I know I finalize it or I know how to make it. But yeah, now I'm thinking I wonder, are these boards good for the so say I at some point I know how I'm gonna wire it, right? I want to basically have everything go to one board and have the board have these connections, connect everything together. But I don't know what is if you guys can recommend something.
Give me a second. I'll look one up on eBay. Let's see.
Doug, I was going to ask about this whole thing about soldering. I'm only soldering the part that actually goes into the last part of the crimp, not anything before that. So it's only the part that's inside the metal connector itself, not the part that grabs the wire, the insulation. So I don't know how that would weaken anything.
Well, I'm just telling. I wanted to tell you that yes, that's the recommendation that they'll make.
Even the insulation will get stiff. The water, some of the solder will wick up into there, and so you have a place where basically the wire is stiff and a place where it's flexible, and that's a weak point. But Murray, I do the same thing.
Okay, because actually, my experience, I've made, dozens and dozens of these little wire things now. I don't even know how many. And as soon as I started soldering them, I haven't had one connection problem.
Yeah.
A testimonial.
Yeah. Oh, I was going to mention, John, their Adafruit makes a whole series of these, and the ones you're showing don't have any traces on the back. This one has little linear traces for power and then for connections to ICs and things. And these come in like 3 different sizes, and they're not that expensive, and they have holes drilled and everything. And these are a really nice high quality PC board. So the Adafruit ones are good, and they even give you them free if you make an order of a certain value.
Nice. Okay. Okay. Good. Good. Yeah. So I mean, I think at some point, maybe next time when the connection has problem, I'll go to this correct way of connecting things.
Don, I have one more graph if I could put it up on the jump start of the motor that Pat was talking about.
Yeah.
Let's see. I say present now. My entire screen.
Yep.
Uh-huh.
Did that do it?
Here you come.
You're getting there. Yep.
Okay. Do you see a graph?
Yep.
Yep.
Okay. What you're seeing here, just look at this top part. It's showing the controls signals that are going to the motors, and then also what the motors themselves are doing. And this is the robot driving along, accelerating in a straight line, then he comes to a stop, and he rotates around, and he does the same thing. So if you look at the part right where it's going through 0, you can see that the control voltages suddenly drop from a value of about 150. Now this is of 0 through 1,000, so call that 15%. They suddenly drop down to 0, and then they suddenly move up, like you can see this pink one here. Whereas the actual velocities themselves are very smooth through 0. The velocities of the wheels themselves. And so that's what I'm saying. That's what the speed controller does for you. He will keep the velocity constant, even if that means having to jump the voltages back and forth around 0. Does that make sense?
Yes.
It's the integrator, right? But it's such a sudden change. I mean, you don't have any special logic. Just let the PID do it. It'll jump.
The PID covers a lot of sins. And I will say this, that when I really want to check out a PID, I run my robot real slow down in the area where it doesn't really want to. It wouldn't run if I set those voltages, tried to set that speed. And you know, if it's the PID is right, it'll just chug right along at that little slow speed without any problem. Anyway, I sent you a link for what they call it a sensor board, and this is they're not very expensive. They're all pre-soldered and everything, and it gives you a ground and a power and a pin out for every pin on the Mega, which makes it really handy. And I think that costs about $4, about $4 to $5.
You know, Doug, the very first time I had my PID controller running, and I did what you said, I ran my motors really slow, and I grabbed the wheel or the robot hit a bump or whatever, and the very first time I saw the robot kind of give it a little jerk and push a little harder, it was the first time I thought the robot seemed a bit smart.
Yeah.
Kind of this sense of like the robot was trying a little harder, you know?
Yeah. That's the other thing that shows you that you're working. If you're running your robot and you hit something and it stalls, then your PWM isn't working. I mean, excuse me, your PID group's not working. Your PID should try harder and harder and harder until it can't try any harder.
Yeah.
This takes it back to the octopus discussion.
Yeah. Yeah.
Because, well, it struck me, the example I gave was my gripper, which grabs on its own. But as I thought about it, the more I thought, well, the balancing robot's probably a better example, because the balancing algorithm reads sensors and drives the motors directly and keeps the robot balanced. So it can respond to shoves and things that the main controller knows nothing about. But then when I thought about that, I thought, well, the truth is that the balance algorithm is really just a fancy PID controller. That a PID controller itself also represents reading sensors directly and directly controlling the actuators without any interference from the main controller.
And is that intelligence?
So that made me think what Carl had mentioned before, where I was trying to make a distinction between working on robotics at the brain level versus the backbone level. But octopuses don't have backbone, so we need a different terminology.
The GUI center.
They work in the GUI center.
Getting inky here.
Hey, did you see my octopus t-shirt?
Yes.
Oh, you have?
Yeah. That was brilliant.
Yeah. Little sad.
Clams are dumb as hell.
What's that?
Clams are dumb as hell.
Clams are dumb.
And it really looks like the octopuses have a lot of fun having sex.
Wow. Yeah. I want to be reincarnated.
There you go. Sad thing, he only lasted a year though, at least that species.
You get. We better not go down that road too far, but yeah.
Yeah.
Both of those videos are really fun.
Yep.
My partner and I actually found that guy that with a weird French or European accent that did your video, Ray, and went through a bunch of his other ones. They're all just really stupid and funny. Thanks for that.
Sure. Yeah, I thought it was a pretty good little documentary, I guess you'd have to call it.
Yeah.
It was good.
I've got a little bit of an update.
Oh, great.
What's going on, Pat?
So I ordered a motor driver. I did get confirmation it has shipped, and I believe it actually is on a ship. So it's somewhere between China and Canada.
Sounds like progress.
Yeah, so I'm hoping 10 days or so I might see it come in. In the meantime, I've been working on my Python and my Arduino. I've got the communication going across between the two. I'm using USB serial, and I'm using using a serial transfer routine. I found a library, and it encodes a little packet and basically sends as much data as you want back and forth. You can do a mixture between floating point, integers, characters, all sorts of different things. So it took a little bit of fooling around, but I did manage to get it working. So I wrote up a Python routine to communicate with it on the Raspberry Pi, and it's running at about a 20 hertz loop, and so it'll send out an X velocity and a Z velocity, and then in response, basically the same time at the 20 hertz routine, when I receive a code, I respond back with left encoder, right encoder, left amps, right amps, and battery voltage.
That sounds pretty cool. I'm going to try to work that out myself in the future.
Okay, so while we were on the meeting tonight, I did the other one is to get the encoder values working, since I don't have a motor driver, I put a timer routine, a timed interrupt routine on the Arduino. So I'm interrupting at 63,000 hertz, so 63 kilohertz, and I still have time left on the Arduino to do some more processing. I have to see if I have enough time to do a couple PID loops in there. Once that's done, that should be the code for that Arduino.
So Pat, did you say you found a nice library for packaging data to transfer over USB?
Yes, I did.
Can you put the link on the chat?
Yeah, I can actually. Let me find it again.
Hey, Pat, where are you located?
In Northern Ontario.
Ah, okay. My family's out in Alberta.
I have my sons are in Alberta.
Ah,
So
small town?
I am in a little town in Northern Ontario. I'm about 70 kilometers west of Sudbury, Ontario.
Oh, yeah.
If you look on a map of North America, you'll see the Great Lakes. In the Great Lakes, you'll see the world's biggest freshwater island. I live about 70 kilometers north of that island.
Ah, wow. Moose?
Pat, you
Area.
might describe to Murray what you're working on. You may remember last week that when you were talking about the Python and working out a subsumption stack that Chris mentioned, oh, too bad Murray's not here because that's right down his alley. You might describe to him what you described to us.
Okay, well, I'm just going to paste the other link in here.
Okay.
Without hanging up on like I did last time. So I pasted two links. The one is a Pi serial transfer, and the other one is a serial transfer. So it's used, the serial transfer is used on the Arduino side, and the Pi serial transfer is used on the Python side.
Cool.
Took a little bit of playing around to get it to work and figure out that the integers were int32s. But I've got that going across, and I don't know, I could share my screen.
So you mean every 32-bit on the Python side, 16 on the Arduino side, or something?
Yeah. Okay. How come I have so much trouble with that? I thought with the pop-up.
You have to click on the little window of the screen.
I'll just present my entire screen. Share.
There you go.
So I don't know if you can see that. Basically,
Yeah.
it's my Python routine, and I'll just run it. Probably it'll be too fast for you guys to see.
Oh, we see it scrolling.
Everything's scrolling.
It's good updates, right?
So so right there, I show my my milliseconds since the last update. So 51 milliseconds, 50 milliseconds. I do a loop counter where I count empty when I'm not processing anything. So I do 4,500 counts roughly, where I'm sitting idle, waiting to respond to the next request. That's just a value I put in to keep it place. And then I have my two encoder values. They're identical right now because I'm just using a timed interrupt routine, and I'm just incrementing the two encoder values. And then on the Python side, I send an X velocity and a Z velocity. So right now it's just as well sending two placeholders. But that's working pretty good. It seems to be pretty reliable. I've had it running a couple days, and then I put a watchdog in on the Arduino side. That if I don't receive a command from Python after 100 milliseconds, I stop the motors. And so
Heartbeat, basically a heartbeat.
basically a heartbeat. So if I don't see some data coming in, stop it. So, and that seems to be running very reliably. For now, I'm just turning on an LED, but that seems to be working well.
That sounds great.
Well, thanks for that update, because I was getting ready to look at that very thing between the Pi and the Arduino.
So I don't know. I don't know if you can pin my screen. Maybe I can bring my laptop over and show Murray.
Yeah, I can pin your screen.
So
Hey, how come you guys aren't?
That's right, Murray has things good, but
there's the robot. So the wheels are about 6 inches in diameter. And it's made out of wood. Has an 18 amp hour wheelchair motor in it.
Yeah.
So it was working. I did have a driver, motor driver, but it died. It won't come out of reset reliably. And it basically, I can't communicate with it anymore. So I've basically given up on it, and I'm rebuilding it. So I'm working on Python and Arduino. I'm using USB serial to do my communication. And one of the problems I have, because I have an Arduino Nano that's running a ring of ultrasonic sensors all the way around the robot. So I have 6 ultrasonic sensors that I'm continuously pinging and receiving a response. And then I have the Arduino Uno that's going to be driving the motors. And one of the problems I was having originally is that the USB is arbitrary which Arduino it brings up first. So which Arduino becomes TTY USB 0 and which one becomes TTY USB 1. So I wrote a rule under dev rules, UDev rules, and basically I look at the path for the USB ports. And whatever is plugged into that path, I give it a name. So now I call it TTY USB motor, or TTY USB ultrasonic. And I can use that into Python code to pick up the proper port all the time.
Now, Pat, are you using the Arduino wire library by any chance?
No.
Because I know that I was playing with Arduinos last year, and I know that a lot of the Arduinos are fine, but using the Nano with the wire library, and you might not even know you're using the wire library because it's used as a main library by other libraries, but you might find out because I think the Nano has problems with the wire library.
So I was using the wire library on my Nano, and I did not seem to have any problems, but it was using as well ROS 1.
Okay.
So I was communicating to the Pi over with ROS 1. I've since been looking at switching over to ROS 2. But the problem I have with ROS 2 is that they won't talk to an Uno or a Nano. The processor is too small, not powerful enough to communicate. So that's why I wrote a routine in Python to do the communication over USB.
Okay.
So that Python routine will probably be talking to ROS in the background and to communicate back and forth to the main routine. Just because there's no easy way in Python really to separate out all your routines and basically have them communicate between inter-routines without calling them from inside a main routine.
Right.
And
I ended up implementing a message bus and then sending everything over a message bus in Python.
Okay. And so I was looking at it. That's why I was looking at ROS as an underlying communication with the communication. It seems to be very robust. Even if I don't use all of the features of ROS, I could still use that base communication layer. It's there. It's error. It does its own error checking. And it's easy to monitor and troubleshoot and all the stuff that go with it. The one thing I am doing is all of my motor control is done in the Arduino. So I send it an X and a Z, basically velocity, and it takes care of setting those speeds.
Right. Yeah, there's been kind of an ongoing discussion, which was the octopus discussion as well, about robot design and having like a central brain versus sending some of that or offloading some of that responsibility to sub-processors or to sensors. And so one of the things that I've been using is these Thunderborg motor controllers, which are I²C. And so I just send it a 0 to 255 or minus 0. I can't remember if it's, anyway, I just send it a number and I get a response from the motor. And that simplifies not having a PWM and having that responsibility on either an Arduino or on a Raspberry Pi. But it kind of gets to that same thing of just basically offloading the responsibility to a processor.
Yeah. So the only thing I'm sort of worrying a little bit about is 20 hertz accurate enough for the encoder feedback? When I'm looking, each encoder at max velocity would be putting out 30, let's say 31 or 32 kilohertz. So when I look it up, it's about 3,150 pulses in between refreshes, basically, to the Pi.
I think David might have an answer for that one, but it doesn't seem to be a problem.
Yeah. So it's a,
the
I'm using a
dynamics of
100
the-
pulse encoder and a 132 to 1 in reducer.
Yeah, your feedback, if the hardware you're controlling is, let's say, a few hertz, then 10 times of that frequency is enough. So, I mean, imagine your how fast you can oscillate your car, right? So it should be very slow.
Yeah, that's what I'm guessing. It's just if you're looking to go forward 3 inches or 6 inches, or you know, it doesn't take long to get up basically that far. In my case,
so are you worried you're getting too many encoder counts per time interval?
yeah, I'm worried that I may not have enough refresh intervals at 20 hertz. I'm not sure. So if I'm going flat out,
because usually, I mean, sometimes the problem is reversed, right? If your
Yeah.
encoders are not very good and you're just getting a couple clicks per revolution, and you're running at too fast of an interval, right? Let's say what are you doing? You're doing 20 hertz, you said. If your encoders are too slow, then you're not actually giving it enough time to accumulate encoder ticks. But you have the opposite, problem, but I don't think it's a problem.
With my old encoders, I had 32 pulses per rotation on my wheel. And the problem is when you have a 6-inch diameter wheel, that's not a lot of pulses. So the only way I could get it to actually, in a PID loop, to work half decent is when I jumped to my interrupt service routine. I calculated a speed in the interrupt service routine based on, only 3 pulses or 4 pulses went by.
That's what I'm saying. In that situation, 50 milliseconds is actually too fast because you're not allowing enough time to accumulate information.
Yep.
But then, you can't run that slow. So, but you're getting lots of encoder ticks. I mean, who cares if you're getting 1,000 encoder ticks every 20 milliseconds or 50 milliseconds, or if you're getting 1 million encoder ticks? I mean, it doesn't really matter, right? As long as everything is properly calibrated.
Yeah.
Where's the question? Should we change the 20 hertz sample rate to 50 or 100 hertz sample rate, since we have plenty of resolution in encoder ticks?
Yeah, I do have plenty. I do have plenty of resolution in encoder ticks. I could increase or decrease my communication frequency as well.
Well, what you'd like to have is say about at least 100 ticks in your sample interval.
100 encoder ticks.
Yeah.
So I have
or more.
3,100 at full speed.
That's okay.
That's good. That's great.
Pat, I just checked on the RCAT robot, and I have it set, at least in the notes, it says 3,834 ticks per inch.
Okay, you've got quite a bit.
I got a shitload, but better more than not enough. I'm with Chris there. All having a whole bunch does is it makes your math really precise.
Yeah, well, that's what was happening when I had 32 ticks per wheel revolution. My math was not accurate at all.
And you do have enough to go our sample rate if you desire.
Yeah, that's why I was saying that you need sort of a minimum of, say, 100 or so to get any accuracy. As a lower limit is how many ticks you have per sample period.
But it sounds like you could speed up your sample rate and get a faster response on the loop. Give you more options.
I did basically the same thing on that robot at any rate, which was I arbitrarily defined slow speed as 1/10 of full speed. And I wanted to be sure I had enough encoder ticks at slow speed to do good PID.
But if he's getting 30-something ticks per revolution of a 6-inch wheel.
No, that was the old design. That was the old design.
That was the old design. I had to calculate a speed inside the interrupt service routine for that one to be any sort of accurate.
Okay.
So I counted my last interrupt with the present interrupt and how many milliseconds elapsed to calculate a velocity.
Well,
Yeah.
that's the other way you can do it, to measure time between pulses rather than number of pulses per unit of time.
Yeah, well, that's what I had to do because it was way too slow.
Yeah, Pat, just to give you an
That'll
idea,
work.
on my robot, which uses these motors, these 9-volt motors, I and my encoders were giving me 494 ticks per wheel rotation, and so if you figure out that's not a huge resolution, but it was fine. I did the math on it. It's 2,295 steps per second to get a 1 meter per second time. You just do all the math to figure it out, and you've got plenty of room for for accuracy. I mean, you're what 4-5 times mine, and mine's fine. I mean,
Okay.
in terms of math, should be fine. 3,000. I'm envious. What kind of encoder do you have?
It's just a 100 slot encoder. I got it out of BC Robotics, actually.
Oh.
Basically, it's a quadrature encoder. I'm not using the quadrature part. It's pretty easy. If I tell it to go forward, it's going to go forward. I know that already.
But it's optical?
It's an optical encoder.
Yeah.
And it's on a motor shaft.
Yeah.
So, and then 132 to 1 gear ratio at 19,000 RPM max on the motor.
Wow.
So
yeah, this is 185 RPM on a 1 to 45, and I'm using Hall effect, so it's just 4 pulses per turn. So yeah, I can see how you're getting that. That's pretty cool.
Well, I didn't have a lot of choice, and when you're up here, part of the problem is we don't have a Tanner's nearby. So
neither do we.
When I go to buy hardware, it's a 632 or an 832, or I might be able to find a 4 millimeter. But I tend to end up buying online a bunch of the little kits with all sorts of metric hardware to get the small hardware I need.
Yeah, Pat, it sounds like maybe rural Ontario is even worse than where I am in New Zealand.
No, this is better. I used to live in Sault Ste. Marie, right at the middle of the Great Lakes.
Yeah.
And I always used to either go home or go to Sudbury, 2.5 hours one way or 45 minutes the other to get to a big city. Now I hate going to the big city. I live in a little town of 5,000 people, and sometimes that's too much.
I live in a town of 1,500.
Pat, I was going to add to that. My first impulse when you said you weren't using the quadrature was, well, you'll want it when you implement odometry. But as I thought that in my head, I also remembered my first robot, which did not have quadrature encoders. And in order to do odometry, I just took the sign from the last command. And that worked perfectly fine. Rather than getting the sign of which direction the wheels, as you say, you know which way you told them to turn. Also, if you're not instantaneously going from forward to reverse, if you're slewing as you go through 0, I never found it to be a problem. I will add on top of that, the encoders I'm using on this robot are the standard one Pitman cells that are 512, maybe it's 500. I think it's 500 lines. And those are quadrature, and you can trigger on both the rising and falling edges, so you can get 1,000 counts per revolution, which is what I use, which is really nice. And as I say, you can always throw them away if you feel like you have too many.
Yeah, well, that's when I interrupt. Well, yeah, you can take one off. Right now, I'm looking at doing just rising edge. If I do decide to use quadrature, then it would be probably just the same thing, rising edge, and then look at the other pulse to see where it is for direction.
Cool.
That's what I mean.
Oh, go ahead, Pat.
Sorry, I said that's it for. I don't have anything else.
Well, actually, David had mentioned you were doing something with subsumption architectures.
Yeah, that's the plan. So this thing isn't going to be. It's not going to be to run in a contest or anything. It's just basically to run around the house and annoy my wife when I'm not here. So I'm looking at using subsumption architecture in the Python, and basically to control everything else.
Cool.
So that's the plan. How far we go with it, I don't know. I've done other work in the past. I've been in robotics for too long. About 30 some years, let's say. Played around in the early days with some HC11s and 2 servo walkers, and I did some mini sumo running around just back then, detecting the line and backing up, pushing away. Never entered a contest. They're too far away.
So you're familiar with Rodney Brooks and all that at MIT then?
Yeah, so I had Rodney Brooks, or not Rodney Brooks, but the first book, Mobile Robots, talked about his subsumption architecture.
Yeah.
I had bought that, I don't know, 20 years ago.
Yeah.
And
Yeah,
then
David recommended that to me.
so there was a new one they recommended. I caught it on YouTube in the video. So I ordered that on Amazon and bought it used on Amazon and had it shipped up. And I gave it to my wife. I said, here, throw that in my stocking.
David, you're muted.
David, you're muted.
Pat, you know that Donna has solved your distant mini robo problem.
Yes, I know. I thought about it, but I'm nowhere near ready to go. I'd have to get one back together, and I'd have to get a ring to practice on. And
You need 2.
well, you need 2, exactly. And the other thing is when I watch the videos, I'm so embarrassed. I'm not even in the ballpark. It's where the whistle blows and you watch my robot get pushed out of the ring.
Yes, some of us would be lucky to have the robot not run itself out of the ring, right? That's...
Yeah, they've done that before too.
Cool. All right.
Yeah, Donna, I will be trying to get online and watch the contest. It's the
global participant, global audience, Donna.
Yeah, there was Seattle Robotics Society has put out a lot of stuff over the years, and when we were far and few between and hard to get to groups, they used to put out a couple newsletters and some articles, and same as the DPRG, and that's where we spend a lot of time reading and watching videos and finding out what other people are doing. And that's where you find out, oh, I got to really step up my game here. I'm so far behind.
Can I go? My cheeks are getting numb. I don't mean these.
I think that's it for me as well, guys. It's 11:23 here, getting pretty late.
Yeah. All right. Well, if there's nothing else, then let's break for the night. And Saturday, elections and annual planning. Bring your ideas. Bring your volunteering.
It's at 1 o'clock, right?
1 o'clock Dallas time.
Okay.
Alberta, New Zealand. I mean, Connecticut. I don't know what time it is anywhere else, but
is that election email possible, or have to be present for that election?
Email is fine.
Oh, was there something related?
Look at the web. Look at the web on the website.
It's on the website.
Oh, on the website. Okay, got it.
We're welcome even if we're not members.
You can vote. You can vote.
You can vote, but it won't be counted.
Definitely would like to have your impact because.
Why can't I vote? Because I did vote in your last election. I voted twice.
Voted twice.
Okay.
I'm just saying that.
If we can't vote, can we at least protest?
Yeah, outside, outside the building, you can protest.
We could demand a recount.
I think I'll be protesting depending on the outcome. But if you check the Slack, I put in a link to where you can read more about that on our website. So so members and non-members, dead people, whatever, everyone can vote, I guess, and then they'll just sort it out with the hanging chads when the time comes.
Yeah. But what we really would like is the input on people. This is our annual planning meeting where we try to get ideas of what people want to hear about, and also who would, like Carl said, would volunteer to give a presentation. And sometimes they get lively for a robot club. So anyway, it'd be fun. Make sure you can at least visit in and see what's going on. Carl, we need to probably step up our game and getting people to vote. So, because
I haven't heard from Ron.
I haven't seen anything coming. Ron said he would do it, but that's okay. Just it goes to election at election
DPRG.org.
Yeah,
Yeah.
DPR.
It's in the post you put on the website.
Yeah.
I popped it open and I'll shut down my computer for the night.
Okay.
All righty.
Bye,
Guys,
guys.
Thanks, guys.
have a great night. We'll see you Saturday. Bye.
See you Saturday.